And good afternoon, or good morning if you are somewhere in Europe right now. We are going to quickly start this second track with Wenxiang Chen, who is giving us a pre-recorded talk exploring and exploiting the SQLite finding more bugs by targeted fuzzing.
Hello everyone, thank you for listening to my talk, Exploring and Exploiting the SQLite, Finding More Bugs by Targeted Fuzzing. My name is Wenxiang Chen and I am a security researcher of Tencent Blade team. I work in fields of web browser and IoT, and recently I am working on security of virtualization. Yeah, those cloud things. And then let me introduce my team. The Tencent Blade team was founded in 2017, and we are focusing on security research in the fields of AIoT, mobile devices, cloud virtualization, blockchain, and so on. And we have found many vulnerabilities and have reported them to their vendors. And here is the outline of my talk today. And first, I will present an overview of the vulnerabilities and the findings of the father. And then the background about the previous research and why we choose this target. And a simple introduction of strategies of manual auditing the code in case you are wondering how we found these vulnerabilities. And then the implementation of the father, the design concept, and how we exploited them in TEF Cup 2019. And last, a bit concluding remarks. In November 2018, we discovered 5 vulnerabilities in SQLite together called Magellan. And since then, many new protective measures have been introduced into SQLite, especially WebCircle, because of Magellan that we have reported to Google. And this year, we have found many bugs in SQLite too, and especially in FTS3 and FTS4 extensions. 3 of them can chain together. The first one, the 13750, this one can bypass the defense in depth, and the following 2 to cause remote code execution in Chrome through WebCircle, or any binary built with SQLite, enable FTS3 and allow external circle queries to be run. And the vulnerabilities are discovered through both manual auditing and fuzzing. And after we reported all the vulnerabilities to Google and SQLite, we also committed our further to Google and named SQLite 3 Shadow Table Further, and it is now running under Cluster Fuzz. I can tell you that this one has found many bugs. Yeah, it has found 6 more new vulnerabilities or bugs in the first week and many more in the following weeks. And here is a list of the bugs it has discovered. Yeah, let's continue. You might be curious about why we choose FTS3 again to audit, and here is why. The first, it is complicated enough, and the FTS3 is created in the form of virtual table, but every FTS table has additional 3 to 5 real tables called shadow tables. They are related to each other. And then comes the oldie and goodie SQLite. It can be reached from the remote. Chrome or any browser or app that is using Chromium can be reached through the WebCircle. Yeah. Also, there can be some attack surface in other places, such as the server with something like PHP with SQLite, and if they support FTS3 and accept remote queries, they could also be affected. Also, it is very old, and here's a snapshot showing the first few lines of FTS3.c file. It says that it was written from almost 14 years ago, and compares to the standard queries that are often well tested by fathers, and FTS is included but intermingled with lots of standard queries. It is harder to reach. For example, Google's father, so it is expected that it is less tested. Last year, we had a talk in another conference in China, and that talk about how we audited the lexical parser, especially lex and YCC-like parsers. The lemon parser used by SQLite is very alike to the function of Bison and YCC, and you can see the lemon parser has introduced a security model along its development. Also, based on what we have researched on SQLite parser, we found that it is not likely to have severe bugs, although there can be some minor bugs, for example, null pointer dereferencing or divided by zero exceptions. But this conclusion was done several months ago, and things could change. If you have limited time to audit the code of SQLite, I suggest you can put less effort in auditing this part. Also, we didn't analyze the lemon parser itself, but only the parser code in SQLite. We also have a link to the text version of our previous researches. Yet we don't have an English version, but for your reference, you can just right-click on the web page and translate it into English. The result looks good to me. Yeah, and thanks to the Google and kudos to the machine translation. So then let's talk about the blobs. Complicated components like FTS need to store data in a binary tree and query data from the tree. The easiest way to do this is to store the data in a blob and convert it into a binary tree when needed. The blobs are objects for serialized, deserialized use. I should point out that it's not only in SQLite. If you have noticed any software doing some deserialized stuff, I was talking about converting binary to objects. You may know this often causes problems. The blobs will be eventually represented by real objects. Since SQLite is a C program, the objects are often structures with different types of members. Besides the strings, integers are very common in a structure that controls the code flow. The integer overflow is also common and somehow very hard for developers to find. Even a software with code review may also suffer from this type of bug. Also the signed bit. When it comes to the integer, many often have signed unsigned cast and can potentially cause problems. Also, there are some functions like the realloc. And have they remembered to zero out all the memory allocated? And are the arguments passed to those functions legal? For example, if the code is malloc quote integer minus a constant number, have they tested if the integer is really bigger than the constant number? If you didn't initialize the memory and return them to the user, they can be used to leak raw heap data. This will let an attacker to bypass the ASLR. And here too, former realloc related vulnerabilities in SQLite. Then I think we should always pay attention to some functions that is not designed for daily use, such as performance tracing, debugging, logging. All those functions, they provide external API-like calls, but they are not even listed on the wiki. People barely know their existence, so that is evil, obviously, because that often means they are lack of testing. For example, spatial insert operators can be used to issue commands to FTS3 and FTS4 tables. Even every FTS3 and FTS4 has a hidden read-only column which is the same name as the table itself. So inserts into this hidden column are interpreted as the commands to the FTS3 or 4 table. Okay, let's choose some interesting commands. The optimize command causes FTS3 or 4 to merge together all of its inverted index B trees into one large and complete B tree. Doing an optimize will make subsequent queries run faster since there are fewer B trees to search, and it may reduce disk usage. And the merge equal xy command, where xy are the integers, cause SQLite to do a limited amount of work toward merging the various inverted index B trees of an FTS3 or 4 table together into one large B tree. The x value is the target number of blocks to be merged, and y is the minimum number of B tree segments on a level required before merging will be applied to that level. See, this simple operations are doing a lot of logic, and many of them can trigger problems when the database is modified by an attacker. And the last one, make a fuzzer before auditing any code. It can give you an extra manpower, and sometimes will surprisingly find some interesting problems for you. In case you haven't heard of shadow tables, I will explain it here. The FTS3 virtual table implementation make use of real, which is non-virtual database tables to store content. For example, when the content is inserted into the FTS3 virtual table and the data is ultimately stored in real tables named content, SECDIR, segments, state, and doc size. These auxiliary real tables that store content for a virtual table are called shadow tables. The leftmost column of the content table is an integer primary key field named doc ID. Following this one, column for each column of the FTS virtual table as declared by the user and named by prepending the column name supplied by the user with C and the index of the column within the table, numbered from left to right starting with 0. And the state and the doc size tables are only created if the FTS table uses FTS4 module, not FTS3. And for each row in the FTS table, the doc size table contains a corresponding row with the same doc ID value. The size field contains a blob consisting of many FTS variants. Each variant in the size blob is the number of tokens in the corresponding column of associated row in the FTS table. The state table always contains a single row with the ID column set to 0, and the value column contains a blob consisting of one more FTS variants, where this is again the number of user-defined columns in the FTS table. The first variant in the blob is set to the total number of rows in the FTS table, and the second and the subsequent variants contains the total number of tokens stored in the corresponding column for all rows of the FTS table. And the two remaining tables, the segments and the SECDIR, are used to store the full text index. Yeah. And here's the concept of the structure-aware fuzzing. Let's use Google's introduction directly. The first, generation-based fuzzers usually target a single input type, generating inputs according to a predefined grammar. And coverage-guided mutation-based fuzzers, such as libfuzzer or AFL, are not restricted to a single input type and do not require grammar definitions. So mutation-based fuzzers are generally easier to set up and use than their generation-based counterparts. But one thing, the lack of an input grammar can also be a disadvantage. It can also result inefficient fuzzing for complicated input types, where any traditional mutation like bit flipping, they can lead to an invalid input which is rejected by the target API in the early stage of parsing. With some additional effort, however, that fuzz can be turned into a grammar-aware, structure-aware fuzzing engine for a specific input type. Because SQLite, of course, uses the highly structured text-based SQL language, it is a good candidate for structure-aware fuzzing. And it has a very good description of the language it consumes. So the Google's fuzzer will first convert this grammar into the protobuf format and translate them with rules to standard SQL queries. And I passed all the links here. You can go visit them for the further information. So let's begin from making my father. We can see the classifiers are contributing many discoveries and improve the security level a lot, but individual researchers usually don't have that many computers. So an important way to find security problems quickly is to optimize the fuzzing code. Google has put forward an idea. The structure-aware fuzzing. This kind of fuzzer can be very useful for a program that has to go through syntax patterns first. Our fuzzer is also based on this idea, but it has made some improvements so that we can fuzz effectively with less power and less price. Also, the effect of fuzzing is always proportional to the amount of code in fuzzing that made a writer fuzzer is as hard as writing a good project. If we do not continue to iterate over the fuzzer, it will be harder for it to discover new problems. And we committed our fuzzer to the Google, and here's a link to it. It's now running on the cluster fuzz, and you can also run it on your computer too, and it can be really easily ported to an FTS4 or even FTS5 fuzzer if you wish. I didn't test FTS4 or 5 since Chrome doesn't use them. The basic idea of developing the fuzzers are, first, we should make the data tables available before fuzzing it. Compared to normal fuzzer, this could save a lot of tries. And we should create a table in this sequence. First, FTS3 table F with column A, B, and shadow table F doc size and shadow table F state. This were used by the FTS4, but we just try to find some code passes of FTS3 which will accidentally go across these two shadow tables. Then we will try to mess up the data tables with queries to table F. This is another different point compared to other fuzzers. We only focus one table, and we don't need to fuzz a lot of FTS tables at a time, and this can also make our fuzzing more effectively. And here comes the differences from the Google's fuzzer. This one is a focused fuzzer. We fuzz only FTS3 and FTS4 part. I believe the Google's fuzzer had already covered the normal queries very well. Also, because we are not making a common use fuzzer with a small set of testing targets, we can make a smaller batch code set and reduce the complexity of our fuzzer. And we can use the fuzz data more effectively. And it targets to only a few complex functions, but not the full SQLite. Yes, we know there are many complex clauses like join, unite, but FTS3 didn't have special rules in processing them, so you don't really need to include them to your fuzzer code. We target only select, update, delete, insert verbs. The FTS have many special logics related to these clauses. And an important thing is our fuzzer knows the shadow tables. We restricted the table name to F and which have two fixed columns A and B, and so we can know all the name of each shadow tables. In other words, we are only changing the data within those tables and try to see what will happen. And the fuzzer will modify shadow tables and try to query or delete or do something to FTS table after finishing modifying the shadow tables. Usually, a fuzzer tends to mutate the input with some types of binary data, but not at a whole word. Even you can specify the dictionary. Sometimes the father will still try to change inside a word. And SQL query is very sensitive in the syntax. Failure in the lexical parsing stage could make the father do a lot of invalid tries. And as we talked before, but only a few minor bugs were found in fuzzing the lexical things, so I think there's no need to focus on them first. We can define some shorter bytecodes to represent correct words. The bottom left figure shows that without a dictionary, the mutating can be really painful. The words are broken and generating many invalid tries. The bottom right figure shows an example of encoding of a fuzzing engine. We can use this to reduce the length of text, like select from to only 2 bytes, which is faster and more accurate. Since we have the bytecode in mind, now it's time to design it. We know that the bits are the smallest unit when the fuzzer is mutating its input. The main objective of designing is to make use of every bit to make the test case shorter. Just for illustration purpose, here's a very simple example that we use to design a query. The actual bytecode we used is 16 bits long, which is too long to show here. I will introduce a real fuzzer later, and you can also refer to the source code for the actual case we have submitted. Now let's go back to this simple illustration. The highest 3 bits represent the verb. Let's call it the verb selector. For example, 000 is to insert, 001 is update, and 010 is to insert. And the lowest 3 bits represent the table to perform the actions. Let's call it the table selector. Usually we have 6 different tables. They are SHANG-DE, content, dot size, segment stage, and the direct operation on table F. And as shown on the figure, this 3 bits can represent 8 different tables because the value is from 0 to 7. So it is enough to cover every table here. The following 2 bits are related to the table selector. When verb and table are selected, the meaning of this part is then confirmed. For example, the figure shows we are performing an insert operation on docsize table, and the extra type selector is indicated as 01, a short integer type. And the 01 indicates that the numbers are generated as a short integer, which causes 2 bytes. So the fuzzer will read the following 2 bytes as the data of docsize. And then they putting all this fuzzy stuff together, the fuzzer will finally generate this query using 3 bytes. Insert into f docsize values 0x123. Okay, after you have defined all the logic of fuzzing, here's another tip to make your coding work easier. Sometimes we need raw data from the mutate engine, such as raw strings, integers, and other simple types. We can also define a raw bytecode to represent a symbol type. For example, you can define FF with length and bytes of raw data. When translating raw string, you can also use the X notation to avoid all the annoying encoding problems like apostrophe and double quotation marks. And here is an example of the corpus generated by the fuzzer. And this is also the first vulnerability found by this fuzzer. And the test case is only 10 bytes after minimize. The first 2 queries are directly creating an FTS table and set an extra state shadow tables to it. And the following two queries were generated from 10-byte shellcodes, and after translation, 4 readable queries will be run in the SQLite. I didn't post the bytecode here because I have updated the father several times and the definition of some bytes has already changed. But don't worry, let me introduce how it was translated. Okay, first some background things. The father is based on the left father, so its entrance is LLVM father test 1 input, and you can easily port it into FLFuzz based father. And to cooperate with Google's coding practice, the father is using Google's data provider. You will have never read the related code. And here's a simple tip. And in my father, I only used 2 functions from it. They are first, consume integral. This function allows you to specify a type and it will read corresponding bytes from the fuzz input. And the second, consume integral in range, which almost same as above. It can limit the range of the value. In this example, the return value will be no greater than 7 and no smaller than 0. To simplify the test, we disable the defense in depth in our father. This can be easily done with calling SQLite 3 dbconfig with SQLite dbconfig defensive set to 0. But this also means if you find some vulnerabilities in FTS3's shadow tables and you want to exploit them in the Chrome, you should find some ways to bypass the defense in depth first, because it is enabled by default in Chrome. And when you started fuzzing, the first thing to do is always clean up the environment, drop everything that may interrupt the test. And then we will create the table F and its corresponding shadow tables, as we have mentioned before. I have updated the father several times, and one of the new functions I have added is tokenizer, you will see. The father is try to read a byte from a data provider and then select different tokenizer. An FTS tokenizer is a set of rules for extracting terms from a document or basic FTS full text query, unless a specific tokenizer is specified as a part of the create virtual table statement used to create the FTS table. The default tokenizer simple is used. The tokenizer often used with match operation. Different tokenizer can have different match rules. For example, the Porter will reduce a word by the Porter-Steamer algorithm. It can match different words. For example, if you try to match a word ported in a text, it can also match the word port because they have the same prefix. But this is not the key point of our father, so today I will jump over this part and show you how the father processes the bytecodes. The father we used defined a struct used 2 bytes, as you can see. The first 4 bits are the operation type, and we use this value to select which table to operate, and the following 4 bits are the column operation indicator again. We use this to select which column to perform operations. This value is related with the OP type. And then the 4 bits of circle operation. This is a verb selector and the last 4 bits of select operators. The select operators are usually not used except for the condition of operating directly on table F. Yeah, it's obvious that you will get dizzy now. Let's simulate the running of the father to know how it worked. Please remember, not all members will be used in some situation. Here I will show you a simple translation that will use only OP type and OP circle operation. Okay, let's take this example to see how the father translates OP code to queries. First, the father should read 2 bytes from the data provider, for example, for F21, and then treat the 2 bytes as struct OP data 16, and their binary value is shown in the figure. Okay, let's put them in the struct, and the value of each member is now clear. Okay, you don't need to remember this. Let's continue to move to the code processing part. There are 5 valid OP types representing 5 different shadow tables. The SECDR is 0, a content is 1, and so on. The value from 5 to 7 is reserved for further use. Now it's used to represent the table F itself. The OP type is 4, so we know it is K-state. Now the column OP is related with the shadow table state. Because the shadow table state has only 2 columns, so the operation can only perform on one of its columns. Here we select with the result of column OP mode 2. The result is 1, so we selected the column ID as target, and now its data type is K short number. Then is time for the OP circle operation. This 4 bits member decides the action to be taken on selected table and columns. The shadow table, SECDR, and content has different column types, so they should be treated separately here. And other shadow tables has the same type. The first one is a number, and the second column is a blob. Yeah, they are the same, but just by coincidence. The definition of each shadow tables are listed in the left, and the content shadow table is most special one. It has 1 more column than the FTS4 table. But since we have fixed the definition of table F, and the table F have 2 columns, so F contents will be 3 columns. Yes, one column more than the original table. So which is the first one, doc ID and C0A, C0B, corresponding with table F's column A and B. Okay, let's back to the shadow table state. Because it has 2 columns, so here we will call getValue by type 2 times and generate SQL queries from the data provider. The function named getValue by type basically reads the bytes from the data provider based on types. If the value is a short number, this one will read 1 byte from the data provider and put it into the output stream. Based on my test, the result of using uint8 and uint16 has no significant difference. So to make the input shorter, I choose to read only 1 byte from the data provider. You can make this longer if you want. Also, I treat the string the same as blob because most of the time they are almost the same. If the value is a blob or a string. First, we can read a uint16 from a data provider and read as many as the length bytes of data again from the data provider. After the SQL query is generated, we call run SQL query to run it. And if there's still some data in the data provider, do all of these steps again until there is nothing left in the provider. And this is how the fuzzer runs. And it may sound complicated, but please believe me, if you debug it yourself, you will soon understand how it runs. And hope you can find more bugs using the structure varying fuzzers. And 2 years ago, when we first tried to exploit WebSQL, there was no protection on modifying the shadow tables. This means that we can modify the shadow tables that SQLite use to store real data for full-text search queries. But after that, defense in depth is introduced to Chrome, so that means even you have some vulnerabilities after boil the midnight oil, that doesn't mean you can exploit them on the Chromium because it enables defense in depth. This technology is intended to prevent all modification to its shadow tables. But by analyzing the patch of their last commit on this part, we can see that they only disabled delete, update, and insert on shadow tables. Seems like verbs like create, drop, and alter is not included here. When you notice this, you know Google's bug bounty is waving its hands to you. If you have read the code of how SQLite creates a FTS3 table, you will realize all its shadow tables are just created with normal create clause. So if we drop their table and recreate the same table, what will happen? Nothing, because it is using select on them when trying to obtain blob data from those shadow tables. In other words, SQLite never sees them as spatial tables. It's not represented as some kinds of table objects. They are just treated as a normal table. So we can create some fake shadow tables and write malicious data into the fake tables that drop the legal shadow table of an FTS table. Then we can alter these fake tables to the same shadow table name with a FTS table that was used by an FTS table. We change them slickly and everything works fine. And here is another vulnerability that was found during manual auditing. We are very curious about the realloc, since usually in every program it has relations to many memory problems. Specifically, in some programs that don't check this return that doesn't check the return value very well. Also, realloc doesn't automatically set the reallocated memory to 0, which means if something like a structure with function pointers or pointers to static or global variables were stored in the memory, after the structure is freed, realloc may allocate new memory at that position. Without initialized memory, we can get the old pointers that was stored in it. Here, the function tries to double the buffer z term each time without setting it to 0. The only way to initialize it is a memory copy. It will copy data from the blob to the buffer starting at n prefix, but n prefix is controllable, which means that we can control where it starts to copy data and make it jumps off some uninitialized bytes. And after the operation is done, the uninitialized bytes we have jumped will stay in the blob and will be written back to the database. So we can read from the database again and get those uninitialized data with a single select SQL query. Okay, now we have a primitive which can leak bytes, and it's almost like most likely to let us bypass the ASLR. And what's next? Yeah, usually a memory corruption. Here we can see the code is converting a signed char to an integer. What's the problem here? First, ARoot is raw blob data, which we can use the defensive depth bypass and control its value. And then when C casts a smaller value to the bigger, it will keep its signed bit. So if we set the ARoot with index 0 to a negative number, which is from 0x7f to 0xff, we can get an integer with the same value. Next, the code will use the negative integer as index to get an object, not writer. Obviously, it is reading out of bounds. And then the code will try to obtain block.a from the OOB object as target to memory copy. And other parameters, ARoot and NRoot, are all controllable. ARoot is a raw blob, you already know it. And NRoot is the length of the raw blob ARoot. Yeah. So if we can place a fake object before the real node writer, we can control all parameters of memory copy. But first, we need to find a way to place our fake objects. By reading the code, we know that node writers are created along with increment writer object, which is a variable p writer in the figure. It just looks like the heap data before increment writer is occupable, because we can move the code into the Visual Studio, and here's a trick to monitor the heap allocation and deallocation. You can use the heap snapshot of Visual Studio. Capture the heap snapshot for 2 times. We can know how the heap is used and the call stack when the program tries to operate on the heap. And also the most important thing, what is ahead of increment writer and what's its size? After we know that, so we can do heap function to put our fake objects into that position. And don't forget, we can move the pointer to very front of it because the size of node writer is pretty big. So we can find somewhere which is empty and use APIs from SQLite to put our fake objects there. After we have write what were primitive, where can we write to? Normally, to exploit SQLite, SQLite 3 config will be a good place to write to. It's not only because it is a big global variable, and it's also because SQLite will refer to this variable to know which memory allocation function to call, because it has many function pointers inside it. Usually after memory corruption, the status of program will be very unstable, but this gives us a chance. We can disable all memory operations such as malloc, realloc, free, and we can just simply change their function pointers to not all our rope gadgets. First, we can override SQLite 3 mem methods.xFree to a function of nothing to prevent any method from freeing the memory. Because after the write was where memory copy, the code will mess up the whole heap and try to free an address from the center of our fake objects, which will make an instant segue of our program. By overwriting free, we can let the program run smoothly without trying to operate on the heap. Then overwrite realloc to the first rope gadget. When realloc is called, our shellcode will run. And leave other function pointers as is. No need to overwrite malloc because we will need it later. And here is a part of our code in Chrome to exploit the first one, 2019-13751 uninitialized data read in SQLite. And we first using the 13750, which is a defense in depth bypass in SQLite to create a malicious table. Then we put the code leaking as many data as we can. Based on the leaked data, we try to calculate the address from the heap data. Because the heap that the FTS queries are used are fixed during every run, so basically we can expect to reuse the same heap every time. The heap will contain some old function pointers like the VF table or page stress of SQLite 3, which is used by other functions before. This is because there's almost no one using the dlmalloc, and this heap is only used by SQLite itself, so it's very stable to exploit this. After we get the address, we can pass the base address to step 2. And this is our final POC of code execution part. The base address of function exploit is to get from the previous step. And we first set the malicious data into the FTS table, and then we try to create hotspot on heap and place the fake objects there in the for loop. You can see it. We call the select replace hex 0 blob many times. This will create a hotspot for us to put our fake objects there. And the last one, after merge equal 1 2, the vulnerability is triggered. And here, first we will try to overwrite the SQLite 3 config. We found a global space before SQLite 3 config, which is not used by anybody. We put the rob gadgets there, and we will overwrite SQLite 3 config also. So I got a snapshot of normally how does it look like in Chrome, and then set the data to the same value as normal time. The only thing is I need to modify is SQLite 3 memfree and SQLite 3 realloc and xinit, xshutdown. The xinit and xshutdown are two function pointers. They accept one parameter, but normally no one will call it, so it is okay to set them to other value. I overwrote the SQLite 3 memory free to assembly return, so it will literally do nothing. And the realloc points to xinit. Xinit and xshutdown points to the first rope gadget. You know that realloc takes two parameters, and RCX is the heap address, and RDX is the required size. So we can have RCX, which is a heap buffer. And usually after the arbitrary write, there will be a realloc, and the address is the start address of the rope gadgets. This is a part of chaining rope gadgets. The rope 1 is called with a known RCX. The RCX is pointed to the first byte of the shellcode. And the figure 1 shows the value of the shellcode part, and the figure 2 is a rope gadget part. We found that gadget, we can use it to control RDX, RAX, RCX, and jump to RAX finally. Yeah, we can control a lot of registers, but the content of RCX is controllable, so we simply put the value to offset 0x3, 0, 20, and 28 in sequence. The RAX should point to rope gadget 2. The rope gadget 2 stores the current RSP value, so we can restore it back to correct value after the exploitation. The rope 3 is a stack pivot. The rope 10 will jump to virtual protect to set the global data to RWX. Then we can run our shellcode. We have a bunch of knobs here because the virtual protect will write something back to the stack, so this buffer can prevent it destroying our stack. And after the loop area here, we try to call the virtual protect again to set the code page of global read-only zone to writable. After that, we can modify a read-only string navigator.appName. We changed it and set the value of it to Punscape to show that our exploit has succeeded. Yeah. Also, we need to restore the stack pointer after this step. We subtracted stored the RSP and restored it into correct value, so everything is rewind to the time before we exploited it. And since programs are expecting this to be a realloc, but we are not doing anything related to the memory, so we must return fail now to make the program think that there's some memory problem and tries to give up its operation. This can stabilize the problem. This can stabilize the program. And once our shellcode is run, we don't need to get into here another time. So we can set realloc to another code pattern that's always return fail. And the web page will not crash, and JavaScript can still run as usual. Everything is fine, except the web circle in this tab cannot work properly. Normally, the bypass of ASLR is almost 100% of success, and the success rate for the second step, the code execution, is about 16% per try. And here's a small tip. If you want to increase the success rate, you can use the iframe to visit a lot of exploit pages, which are located in different domains. So Chrome will have different process with each iframe. And we only tried once in the TenF Cup 2019, and the result is succeeded. Yeah, and that's all for the exploitation part. Okay, and here's our conclusion on all of these works. And first, sometimes I think it is better to focus on a smaller scope of functions. The common use fuzzer can save a lot of time in programming, but it will take more time to test a specific area. So you should write a focus fuzzer, especially you believe that some area has lower code quality or they're more likely to have bugs there. And then, regardless of programming language, deserialization can be tricky. That's because deserialization often have external data from users at the input and then convert convert the input to an object. But it is very hard for the programmer to test all the unexpected conditions. So you should pay more attention here when you auditing the code or you are testing the program. And the last one, if memory is initialized according to the user input, you should remember to always zero it before use. It doesn't matter if the memory is based on stack or heap or anywhere. To remember, always clear them, so the attacker won't get useful data from the uninitialized data. Yeah, they may often have some sensitive things like the function pointers or any pointers or even the encryption keys or something. Yeah, always remember to zero it before use. Yeah, that's all for my talk, and thank you very much for your listening. And also, because this is a pre-recorded video, so I can't answer your questions now. But if you have any questions about this talk, please kindly contact my email. It's leonwxqian@gmail.com. Yeah, the email address is the same as my talk. Thank you again, and stay safe. Bye.
Right, like he said, this was pre-recorded. We cannot do Q&A, and we will be back in like a minute or two with Igor Korkin, and kernel hijacking is not an option. MemoryRanger comes to the rescue again.
Oh, good morning, Mr. Cooper.
Right, we continue with Igor Korkin and his talk, Kernel Hijacking is not an option, MemoryRanger comes to the rescue again. Igor, take it away.
Hi everyone. Thank you, Mr. Cooper, for introducing me. I'm happy to be part of this event, and I really appreciate your interest in my work. Today, I'd like to present you to show you 3 hypothetical but possible attacks on kernel data in the newest Windows 10 and a way to win this kernel mode battle. I think this topic is of critical importance for all security experts who are dealing with OS security. A few words about me. I've been exploring OS security for more than 10 years. I'm always curious about attacks on the OS kernel and how to prevent them. You can find my results in my blog. Today, I'm going to talk about 3 hypothetical attacks, 3 new attacks on kernel data. 2 of them show a way how to read and overwrite files opened without shared access. And another one shows how to elevate process privileges. All these attacks are based on patching memory data, and they do not trigger any Windows security mechanisms. I have discovered a technique that can prevent this kind of attacks. I'll show you my MemoryRanger, the tool which is designed to prevent attacks on kernel memory. One of the key features of updated MemoryRanger is a new data-only enclave. I've been developing my MemoryRanger for several years. Here are the corresponding research projects. You can follow the links below to read more about the MemoryRanger. Nowadays, kernel mode OS components and malware drivers share the same memory space with the rest of the OS kernel. All drivers can read and overwrite any part of kernel mode memory without any hardware restrictions. Therefore, modern operating systems are prone to kernel attacks. Look at the recent examples of kernel malware attacks. Robinhood ransomware that exploits a legal vulnerable driver to load a malware driver and disables security products. CryptoMiner that infected over 50,000 servers. It installs a malware driver to protect itself and abuses the computing resources for quite a long time. Gluteba malware that uses a set of kernel drivers to disable Windows security and finally hides its footprints. Our world is in danger. Who can save the world? Let's imagine that one researcher has invented a vivific elixir, an effective solution that can save the world. But here is the hack attacker who wants to destroy the world. He is plotting to steal and modify the formula. It is very likely that he can succeed. That is why I have developed my MemoryRanger to prevent attacks on kernel data. My MemoryRanger guarantees that the secret data remains safe. Let's see how it works. It is obvious that the formula should be kept in secret. The researcher opens a file without shared access. No one can read and overwrite it. And here is a hack attacker that wants to steal the formula and overwrite it. Usually, Windows guarantees an exclusive access to the open file and promises to block all other access attempts. But it is not quite so simple. The attacker can bypass this Windows barrier and gain access to the secret data. Today, I'll show you 2 possible attacks on this kind of files. Let's have a look at the details of file system routines in Windows kernel. Drivers use ZW create file routine to create or open a file. Setting share access to 0 gives an exclusive access to the open file. ZW write file and ZW read file routines are used to write data to the file and read it. Let's have a look at what happens after the driver calls these routines. While calling ZW create file, the control goes to the I/O manager, then to the object manager, then to the security reference monitor, which checks whether the access rights are valid. If access is granted, the control goes to the NTFS driver and then to the disk drivers. Security reference monitor is involved for each call of ZW create file. This subsystem checks the permissions and it can block unauthorized access. For example, it can return status sharing violation. Let's have a look at the details of read and write routines. Functions ZW write file and ZW read file use the same Windows subsystems, but they are skipping security reference monitor. OS uses file handle as a key to traverse through the following structures: kernel handle, object header with file object, NTFS data structures. For each read and write operations, OS gets through all these structures automatically without any security checks. The security reference monitor is not involved. We have two outcomes. ZW create file always performs access checking. ZW read file and ZW write file walk through the file structures without any security checks. This fact can be used by attackers in the following way. So, the secret file has been created in an exclusive mode and it is remaining open at the moment. The attacker can create a file, I named it a file hijacker. OS creates all the corresponding file structures automatically. Then, the attacker can modify the file structures in order to redirect the control flow to the secret file. As a result, all read and write access attempts to the file hijacker will be traversed to the secret file. So, the hacker can use 3 different hijacking techniques: handle hijacking, file object hijacking, hijacking of NTFS data structures. Today, I'll present you the details of 2 attacks: handle hijacking and hijacking of NTFS data structures. The link with the hijacking attack on file object was shown earlier. Let's move on to the handle hijacking. To understand the idea of handle hijacking, let me show you some details of kernel handle table. This table is used to store the mapping from the handles to the corresponding object structures. Windows kernel allocates a new entry for each created file. The entry includes object pointer bits. This field points to the object header structure. OS doesn't check the integrity of this field, and this fact causes the possibility of handle hijacking. Here we have a secret entry for the secret file and an entry for the file hijacker. The attacker can overwrite its object pointer bits using a value of object pointer bits from the secret entry. Now, all read and write access attempts from the attacker will be redirected to the secret file. The legal access will also be forwarded to the secret file. Let's see how it can happen. A researcher will open a secret file without shared access. the attacker will try to access the opened file twice. First, by calling the create file routine, and second, by using the proposed handle hijacking attack. Let's see how it can happen. Let's check the Windows version. We have the final one. The researcher is launching his app, which loads the driver. The researcher is opening a new file. He is writing down the secret formula. He is reading the data to check it. The formula is saved in a secret file, but the file is still open. While the researcher is being proud of his job, for example, having a tea break, the attacker has a chance to steal the formula. The attacker is launching his app, which loads the driver. First, he tries to open the file using Windows function, and he fails. Windows blocks illegal access to the file. He is starting the hijacking attack, and he needs to have a file handle for the secret file. Let's assume that he's got this handle value. We can see that the attacker creates a file hijacker and patches the corresponding handle table. He's trying to read the secret file, and he succeeds. He has read the secret formula. And look, he's trying to modify the secret file. And when the researcher decides to check the formula again, he sees that the formula has been illegally modified. Let's wait for patchguard reaction, which is designed to prevent any illegal memory modifications. We've been waiting for 10 hours. It is quite a long time, and look, nothing has happened. The OS hasn't been crushed. The OS became infected, and the secret elixir is in danger. Okay, let's think about how to prevent this attack. We have to restrict write access to the object pointer bits without blocking write access to the other fields. Also, we cannot block read access to this memory area. My MemoryRanger has been updated to take into account this attack. Actually, MemoryRanger, it is a hypervisor-based project designed to block kernel mode attacks. The MemoryRanger can trap the loading of new drivers and move them to the isolated kernel enclaves. My MemoryRanger can allocate isolated enclaves in runtime with different memory access restrictions. The MemoryRanger allocates the default enclave for the OS and drivers loaded before. To prevent handle hijacking, my MemoryRanger moves two newly loaded drivers into separate enclaves. Next, it hooks the create file routine to locate the created file structures and restricts any illegal access to them. Red line indicate the illegal access attempts. This scheme helps to prevent handle hijacking attack by blocking illegal write access attempts. Let's see how it can happen. Let's check the Windows version. We've got the final one. The MemoryRanger hypervisor is loaded first. The researcher is launching his app, which loads the driver. The researcher is opening the file. He's writing down the secret formula. He's reading the file to check its content. The formula is saved in the secret file, but the file is still open. While the researcher is being proud of his job and, for example, having a tea break, the attacker has a chance to steal the formula. An attacker is launching his app, which loads a driver. First, he tries to open the secret file using Windows API function, and he fails. Windows kernel prevents an illegal access to the open files. He's starting the hijacking attack and he needs to have a file handle for the secret file. Let's assume that he's got this handle value. We can see that the attacker is failing to patch the handle table. He's trying to read the secret file and he can read nothing. He's trying to overwrite the secret file. Then the researcher has finished his tea break and wants to check the formula. And the formula hasn't been changed. MemoryRanger prevents all illegal access attempts. Now let's close both files to compare their content. We can see that the secret file contains only the secret formula and all attacker's input data is saved inside its file hijacker. Thanks to the MemoryRanger, the OS is protected. Okay, as a result, we have the following picture. The MemoryRanger restricts write access to the handle entry and prevents handle hijacking. Now, let me show you one more way, an absolutely new technique to access exclusively open files. It is NTFS data hijacking. Here we have file object which fields point to the control block structures. Let me call them NTFS data structures. These NTFS structures point to the other structures as well. OS doesn't check the integrity of the structures, which causes the possibility of hijacking NTFS structures. Here we have NTFS data structures for the secret file and for the file hijacker. The idea of attack is to overwrite the NTFS structures for the file hijacker using the data from the secret file. This can help to redirect read and write illegal access to the structures related to the secret file. The legal access will also be forwarded to the secret file. While I was checking this idea, I got the following blue screen of death. This bug check indicates that someone tried to release a resource he didn't own. Actually, this is true. I tried to use the resource which doesn't belong to me. How Windows OS has revealed this? The reason is here. Windows OS checks whether the current thread ID matches the value stored in the structure. If they are not the same, the OS calls kbugcheckx, which brings down the system. So, to bypass this check, malware driver needs to copy structures and patch the thread ID. Malware needs to repeat these two steps each time before reading and writing the secret file. Here is the scenario of the demo. The attacker will try to access the file twice using OS API function and using the hijacking NTFS structures. Let's see how it can happen. Let's check the Windows version. We've got the final one. The researcher is launching his app, which loads a driver. The researcher is opening the file. He's writing down the secret formula. He's reading the data to check it. The formula is saved in the secret file, but the file is still open. While the researcher is being proud of his job, for example, having a tea break, the attacker has a chance to steal the formula. An attacker is launching his app, which loads a driver. First, he tries to open the secret file using Windows API function, and he fails. Windows kernel prevents an illegal access to open files. Then, he starts the hijacking attack on NTFS data structures, and he needs to have a file object for the secret file. Let's assume that he's got this value. We can see that the attacker creates a file hijacker and successfully patches the corresponding structures. He's trying to read the secret file. The secret formula has been stolen. He's trying to overwrite it. And then the researcher decides to check the formula. He sees that the formula has been illegally modified. What about patch guard reaction? Seven hours have passed and nothing has happened. The OS became infected and the formula is in danger. So, to prevent this attack, my MemoryRanger implements a similar technique. It runs drivers inside isolated enclaves. The MemoryRanger grants access to the NTFS structures that have been allocated by each driver. The MemoryRanger restricts access to the NTFS structures that have been created for other drivers. So, let's see how it can happen. MemoryRanger hypervisor is the first to be loaded. The researcher is launching his app, which loads a driver. The researcher is opening the file. He's writing down the secret formula. He's reading the data to check it. The formula is saved in the secret file, but this file is still opened. While the researcher is being proud of his achievements and, for example, having a cup of tea, the attacker has a chance to steal the formula. The attacker is launching his app, which loads a driver. First, he's trying to open the secret file using API function, and he fails. Windows prevents all illegal access attempts. He's starting the hijacking attack, and he needs to have a file object for the secret file. Let's assume that he's got this value. We can see that now an attacker is failing to patch the NTFS data structures. He's trying to read the secret file. He reads nothing. He fails again. He's trying to overwrite the secret file. Then the researcher has finished his break and wants to check the formula. The formula hasn't been changed. MemoryRanger protects the file structures. Let's close both files to compare their content. We can see that the secret file contains only the secret formula and attacker's input is in the file hijacker. Thanks to the MemoryRanger, the OS is protected. So, as a result, we have the following picture. My MemoryRanger restricts read access to the NTFS data structures and prevents hijacking NTFS structures. That's all about attacks on file system, and now let's move on to the process privilege escalation attack. Let me briefly introduce this kind of attack. For each created process, OS kernel allocates several internal structures. One of them is eProcess structure, which includes the process information and pointers to other structures. One of the fields of eProcess structure points to the token structure. Information about process privileges is stored in the token structure. Malware authors invented various techniques to escalate process privileges. 10 years ago, attackers could easily add more privileges to the process by directly patching the token structure. Windows security experts prevent this attack by adding such fields as seed hash and restricted seed hash into the token structure. This guarantees the integrity of the token structure. Hackers made one step ahead and escalate process privileges by copying the address of token structure from a more privileged process. This technique is called token stealing or token swapping. Newest Windows Defender prevents this token swap attack by checking the integrity of these pointers. I will show you how attackers can escalate process privileges without triggering any security features. Now let me show you the details of the token structure. The token structure includes two parts, static part and a dynamic or variable part. The static part has a fixed size and has a link to the dynamic part. The dynamic part includes the process privileges, which are stored using a set of seed and attributes structures. Here we have two token structures for a high privileged system process and for the low privileged console application. The proposed token hijacking attack is to copy the whole token structures of the privileged process, including both parts, static and dynamic. Copying the static part is simple. To copy the dynamic part, attackers need to consider the interconnections between these structures. Let's see this idea. Here is the scenario of the demo with token hijacking. The attacker will start the CMD and his application, which allows the driver to escalate privileges. Then the attacker will check that the privileges have been escalated by trying to disable Windows Defender. The commands to disable Windows Defender are borrowed from a banking Trojan called TrickBot. Let's have a look. Let's check the Windows version. We've got the final one. The attacker is launching the CMD. We can see that CMD has users' privileges. The attacker is trying to disable Windows Defender using the commands from the Trojan. We can see a lot of error messages. They are the same and all of them mean that CMD doesn't have enough privileges to disable Windows Defender. The attacker is launching his app, which loads the driver. To start the token hijacking attack, he needs to know a CMD process ID. He is getting and copying the target process ID. We can see that the token structure has been patched. an attacker is checking the privileges again, we can see that the privileges have been elevated. The attacker is trying to disable Windows Defender again, and he copy-pastes the commands from the Trojan once more. He doesn't receive any error messages. We've just received a notification which confirms that Windows Defender has been disabled. The attacker can also disable even this notification. Let's see the patchguard reaction, which is designed to prevent illegal memory modifications. We've been waiting for 10 hours. It is quite a long time. Nothing has happened. The OS hasn't been crushed. It means that patchguard hasn't prevented this invasion. The OS became infected and our data is in danger. Okay. Let's think how to prevent token hijacking. The key feature of the token structure is that token structure has to be used only by Windows kernel, which have to access them. All other access attempts can and must be blocked. My idea is to create a special isolated enclave for sensitive system data. This enclave will include only token structures and Windows OS kernel core. All other drivers will be excluded from this enclave. The token structure will be excluded from all other enclaves. This idea helps to prevent illegal access to the token structures from all other drivers loaded before MemoryRanger and after it. Let's see how it works. Let's check the Windows version. We've got the final one. The attacker is launching his app, which loads a malware driver. Then we're launching the MemoryRanger to protect the OS. The attacker is launching the CMD. He's checking the privileges. CMD has user's privileges. The attacker is trying to disable Windows Defender again using the commands from the Trojan. CMD doesn't have enough privileges. To escalate process privileges, the attacker is getting and copying the process ID. Now, the attacker is running the token hijacking attack. We can see that this time the token structure cannot be patched. An attacker is checking the privileges again. We can see that CMD still has users privileges. Now an attacker is trying to disable Windows Defender again. We can see a lot of error messages that confirm that CMD doesn't have enough privileges. Thanks to my MemoryRanger, the OS is protected. Okay, let's continue. As a result, we have the following picture. The MemoryRanger prevents patching the token structures by moving them to the special data-only enclave. Now, let's move on to the brief overview of my MemoryRanger and its main updates. The MemoryRanger is a tool designed to prevent attacks on the OS kernel with the help of kernel mode driver and a hardware-based hypervisor. The MemoryRanger registers a notification routine to intercept the loading of new drivers. The MemoryRanger allocates a separate enclave for each newly loaded driver. The MemoryRanger also intercepts the launching of new application. This helps to locate token structures and move them to the data-only enclave. The MemoryRanger can hook kernel API functions, for example, ZW create file, to locate the created internal file structures and restrict access to them. Hypervisor controls access to the kernel memory by restricting access and trapping EPT violations. The MemoryRanger provides a flexible memory access policy. The MemoryRanger can be easily updated to prevent new attacks on the OS kernel. Let me recap very briefly on what I have presented and what you learn. First of all, some Windows kernel data can be easily modified by attackers without triggering any security features. We have seen 2 hijacking attacks to access files opened without shared permissions and a new technique to elevate process privileges. I have presented an updated MemoryRanger which can prevent all these attacks. One of the new features includes a special data-only enclave to isolate sensitive data from all drivers. Eventually, thanks to the MemoryRanger, the world is saved. Thank you.
Okay, awesome. Thank you. I am looking at Slido for the questions, and currently nothing is popping up. That could just be because they are still in the mod queue, I'm being told. I will also mention you're getting very high marks for wearing a bow tie. I am still not showing any questions. I'm gonna refresh this one more time, because otherwise it would be just unfair to... Oh, here is one. Do the mitigations provided by MemoryRanger significantly affect system performance?
Oh, I got it. The first question relates to the performance issues and the performance degradation. How significantly performance has been degraded due to using security features. Actually, MemoryRanger has affordable performance degradation. All the details about the details of how I calculated performance degradation and how it can be improved, mentioned in my previous paper, which I mentioned early at the beginning. Actually, absolutely true. It caused performance degradation because at least we need to trap memory access. By the way, it is worth to mention that MemoryRanger is absolutely great solution to prevent access to the memory which doesn't have which access very rarely. For example, token structures, which do not very often accessed by the system. This is a great solution. The problem, the challenge, the hard issue is to prevent sensitive data which has to be accessed in a protected way very often. This is the problem. But I think this is a global problem with restricting memory access. Thank you very much for your question. All the details are in my previous paper.
Okay, then we have another question, and that is there any way for Windows to completely mitigate the entire vulnerability class? And in your opinion, what is the best mitigation strategy?
This is our second question relates to our global problem, how to prevent all vulnerabilities in our world? Yeah, it's a complicated question. Point number one: if we uh, fight with all vulnerabilities, all the security experts will be fired. Yeah, actually, this is very complicated question. The thing is that operating system includes ton of codes, millions of codes, and as I understand, it is extremely complicated to reveal all the vulnerabilities. The idea which I mentioned in this presentation is just a first step to prevent the consequences of exploiting the vulnerabilities. So we cannot reveal all of them, but we can isolate the payload, yeah, inside isolated enclave, and this will prevent attackers, for example, from escalating process privileges. So it can run its own driver. Let's assume that attackers can run its own drivers, yeah, but they cannot patch sensitive kernel data. That's my point. My point is to isolate drivers from each other. Yeah. If you yeah, one point in this question I would like to mention that, you know, in US Windows 10, Microsoft security experts introduce virtual security mode, which provides two modes: secure mode and normal mode. And they implement this feature using similar techniques, using EPT, using second level of address translation. And this idea which I presented you, it's a more general solution. I implement several isolated enclaves. Windows implements just two enclaves. My idea is to implement several enclaves. For example, 3 enclave, 5, whatever. Yeah. If we summarize your question, I think that reveal all vulnerabilities, it's impossible. It's a very tough question, but we can fight with the issue and prevent the consequences of code exploitation by isolating this code. This is my idea.
Okay, thank you. I'm gonna quickly see if a new question has popped up. By the looks of it, it has not. So that was all the questions that we have for you today. Thank you very much for your talk. Will you be joining the Discord channel in a moment to potentially talk to people about this? Was that the plan? I don't remember.
We will see. If you guys have some more questions, feel free to send me a message via Twitter, via email. I really appreciate your time. Thank you, Mr. Cooper, for all your attention, for your help. Without you, it will be impossible. Yeah. Thank you very much. I think we will work on making our world more safe, and finally we will succeed. Yeah.
And
Thank you.
awesome. And on that note, I will say that the next talk will be at 4 p.m., which is by Maria Nedyak on how to hack medical imaging applications via DICOM. Don't go anywhere. and with the music ended at a very appropriate point, we are going live to Maria Nedyak and her talk, How to Hack Medical Imaging Applications via DICOM. As ever, if you have any questions, ask them on Slido, throw them in the Discord, and we will get to them as soon as the talk is over. Maria, take it away.
We will talk about the DICOM protocol, how it is connected with medical imaging, and then we will discuss the results of my research. First of all, let me introduce myself. I'm a student at Tomsk State University, and currently I'm working at Bison company. And also I'm participant of a research group, AISEC team. Now about my team. AISEC team is a group of enthusiasts, and the main goal of our researchers is cybersecurity of machine learning and artificial intelligence implementations. There are some links to our projects. The first link to the project, which about I will talk today, and the second link is a projects link where you can find other researchers from our team. Okay, let's start. Everybody knows that nowadays machine learning evolves very quickly, and one of the most popular applications for machine learning is medical imaging. Medical imaging is an area where neural nets are used to detect tumors, to identify some different diseases and so on, and all is based on X-rays, MRI scans and stuff like that. Data scientists use sets of medical scans to train their networks. These scans are represented in the DICOM format. For medical imaging, data scientists build a huge machine learning pipeline, which includes ML models, converters, DICOM readers, and so on. And while researching the security of medical imaging, we chose not the ML models themselves, but we chose the readers and the converters and tools for working with the DICOM protocol. And after that, we started researching the DICOM protocol in general. And what is DICOM? Or DICOM, or Digital Imaging and Communication in Medicine. It is a data format protocol exchanging between various components. And generally speaking, DICOM has two parts. A file format of medical scan. It describes how scan information is stored in a file, and a network protocol, which describes communication between two devices for transferring DICOM file. At the beginning, I will speak about DICOM file format and how it is connected with medical imaging, and then I will tell about network protocol a little. Why it is interesting to test DICOM parsers for vulnerabilities? All vulnerabilities can influence the whole pipeline, machine learning pipeline, and its result. For example, some ML model is diagnosing some scan for lung cancer. And if an attacker exploits any component in a pipeline, for example, a simple dose of the DICOM parser, the model will give a wrong result. And that's why it is interesting to search for vulnerabilities. NVIDIA Clara. NVIDIA Clara is the most popular machine learning pipeline that deals with medical imaging. Clara Medical Imaging provides developers a set of tools to create medical imaging workflows. And it takes DICOM files as input data. And the model which parses DICOM file in NVIDIA Clara is DICOM Reader. DICOM Reader is a Docker container. You can download this container from the official site. And if you look inside, we can see a Python source code. And as we see, it uses the SimpleTK library for DICOM reading. I used American Fuzzy Loop for finding weaknesses in SimpleTK library, and after fuzzing for a couple days, we finally got a crash that was caused by a heap buffer overflow. And actually, there is a fun story about reporting this bug to the vendor. In reply to our report, the vendor answered me that it is not a bug in the library. It is a bug in our DICOM file, that one we attached to prove the existence of this bug. And they kindly fixed our proof of concept DICOM file and sent it back to us. And fortunately, this story was ended with a happy end. The misunderstanding was resolved, and the bug was fixed in a few days. And another bug which I found in SimpleETK is a classic buffer overflow in patient name attribute. As we see, memory for the patient name is located on the stack, and then the name from the file is copied there without any length limitations. And what we need to do to trigger buffer overflow, we just need to create a DICOM file with patient name longer than 512 bytes, and after feeding this file to DICOM parser, it will crashed with core dump error. And these simple steps are enough to crash in the entire medical imaging pipeline. Okay. The next vendor which we chose for security testing is RTANG. NVIDIA Clara recommends this for input data management. Because it has a web interface and it makes data management more easy. You just need to have a web browser. And RTANG is a standalone DICOM server, which is easy to use. Also, RTANG is widely open for developers. It provides REST API for writing different plugins. Official site says that a lot of medical universities and hospitals also use RTANG already. And on this slide, you can see the statistics of RTANG. There are servers which is running on the internet, and it is popular in America and Europe, as we see. And this statistic is made with Grinder framework. This framework is really cool. I will share information about it at the end of my talk. Okay, to start talking about RTANG, let's talk about RTANG REST API. On this slide, you can see a list of API methods, for example, shutdown methods and reset methods. And also, I think that the most attractive methods for an attacker, they execute script methods. RTANG is open source project, so we can go to the source code to find out what this method does. It turns out that this method does exactly what it says. It takes in a script in Lua and executes it without any validation. On this slide, you can see an example of a request with shell command for creating directory. Okay, it will be a disaster if not the fact that RTANG has authentication. Unfortunately, this authentication is disabled by default when you use RTANG from the official site. It is enabled in the official Docker image, and it will be okay if not one problem. If not one problem, that RTANG authentication doesn't have any CSRF prevention. You can see an example of a CSRF payload, which sends an arbitrary shell command to the server. And in a short words, the attacker scenario is as follows. You host this HTML on your web page and send the link to an RTANG user. And once he opens the link, his browser will send an authenticated request to execute an arbitrary shell command. Okay, of course, I immediately reported this bug to the vendor, that your server doesn't have any CSRF prevention, and considering your insecure API, it may lead to some serious consequences. A maintainer of RTANG answered me that RTANG is a microservice, and you need to create a secured environment by yourself. And furthermore, Artan documentation already has warnings about CSRF. Okay, yes, Artan documentation warns us about CSRF, but I still was a little suspicious about it. And I decided to view Artan documentation in the Google Cache. And yes, here it goes. The documentation didn't have any CSRF warnings just a few days before our report. I think it was a little strange of vendors' reaction to vulnerabilities. To sum up, Artan has authentication, but you need to create your own authentication mechanism. And as far as understood, Artan doesn't care about confidentiality of sensitive data which is stored in it. And I wanted to once again highlight that each DICOM file has personal data about patient, like name, sex, age, and medical survey. Okay, let's move on. The next vendor which we chose for testing is DECEPTICON. DECEPTICON is the first implementation of the DICOM protocol. The development of this toolkit was started in 1993 with the development of protocol specification. And NVIDIA Clara recommends to use DECEPTICON in their workflows. And also Artan use the DICOM server from DECEPTICON as its core. Also, I used fuzzers like AFL and libfuzzer to search for weaknesses in DICOM parsers. It has found several doses in different parsers of DICOM format. And also, we discovered that one of the parsers from DECEPTICON is vulnerable to XXE attack. You just need to create XML file with external entity, and the example you can see on this slide. And after feeding this file to the parser, the resulting file will contain of, for example, etc passwd file. Okay, I reported this bug to the vendor, and the vendor asked me that he can't reproduce this bug on his machine. And to figure out why, I'm going to speak about libxml library a little deeper. Sorry for that, but I think it is important to know. Okay, DECEPTICON uses libxml for reading XML files. There is an Avast page where you can find some information about XXE prevention when you use libxml library. Also, it says that from version 2.9 of libxml library, the functionality of external entities has been disabled by default. And also, it warns us about its dangerous options, such as XML parse node and XML parse DTD load. These options may lead to a vulnerability if you use these options with these functions from this list. Okay, DECEPTICON indeed doesn't use these options for XML reading. We continued to dive deeper into researching this problem, and it turned out that our libxml version was very different. The vendor had a 2.9.1 version, and I had a later version. Okay, on this slide you can see the final fix of this bug, as we see, the solution was simply to change XML substitute entity's default argument from 1 to 0. And let's see what this function does. These functions just changes some global variable of XML parser. And here, the lines from 2.9.1 libxml source code, the ones that vendor had on his machine. And as we see, this variable is used in XML parser initialization. And what happened next in the next version of libxml library? Now it appends a danger option XML parse node to parser options, and it allows the external entities in XML files to work. So that is why XXC payload was working on my machine and not working on vendor's machine. And I suppose that IWASP doesn't have a full information about XXC prevention when you use libxml library. If IWASP contained a note about this function, we wouldn't be so confused. Okay, that is all about my little investigation of libxml source code. And by the way, the XML2DCM parser, which was vulnerable to XXC attack, also has functionality of reading any local files. The idea is the same as with XXC. You just create a file with tag pixel data and put the name of local file, and the result will. And in the resulting file, you will see the etc password contents, for example. And also, this parser doesn't have any keys or parameters to disable this functionality. And vendor doesn't consider this a vulnerability. Okay, let's move on to the network. The COMP protocol describes the communication between two devices. Usually, it is used between database, aka DICOM server, and a scan machine, and also between database and the device where a doctor can analyze the survey. There are common methods of DICOM protocol. The echo method, the echo command is used to test the connection between two devices. The find method is used to search a scan. The get and move methods are used to retrieve image from the DICOM server. And the store method is used to store image on the remote DICOM server. The most of DICOM servers are configured in such a way that anyone can establish a connection with them. It is pretty simple to retrieve images from a remote DICOM server. It can be accomplished in just two commands. You need to know a host and a port of a remote DICOM server, and another thing which you should know is application entity title. What is application entity title? Application entity title is an option of DICOM server. It is used to create some kind of user access. For example, different PAX systems use a one DICOM server. And to set up a different storages, you should use application entity title. It is just a word. And it kindly identifies a user or PAX system to the DICOM server. But this identification doesn't work because all PAX systems use default application entities, and you can just brute force this application entity. And after successful brute forcing of application entity, you can establish a connection with a DICOM server and download a full list of patients by this command, which you see on the slide. And then you pick a specific patient whose server you want to download, and you create a request with getS2 command with a patient name, and by this command from the slide you will download the patient's full survey, and that's it. Okay, here is a statistics of DICOM servers on the internet. An interesting fact that it became more popular in the last year. In 2019, there were about 1,000 hosts, and in 2020, it increased by 2. Okay. As I was focused more on the problems of implementations, I tried to fuzz DICOM network protocol implementation, and I used FLNet for fuzzing. It is pretty simple to expand the FLNet fuzzer. You just need to add two functions for parsing input data and for retrieving a status code from service response. And I have added DICOM protocol to the FLNet repository, and there is a link where you can read a tutorial of how to use FLNet to fuzz the DICOM protocol, and how I expanded FLNet for DICOM. Here is the structure of the DICOM packet, and I used PDU type as a response code, and the parsing of input data was based on PDU length. And here are the first results of fuzzing the DICOM server from the DCMTK. I have found a few doses, and all these doses were reported to DCMTK. Okay, now I want to summarize my talk. I will state several points. DICOM operates on sensitive data, such as personal info and medical service, and default configurations allows anyone to retrieve this data. DICOM tools contain basic vulnerabilities like CSRF, XXE, insecure functionality which allows you to execute a code on a remote machine, and also buffer overflows, heap buffer overflows, and a lot of doses. And all of these vulnerabilities can influence the whole machine learning pipeline and its result. And I think that the DICOM community and vendors mostly pay little attention to the confidentiality and security of their services. And before finishing my talk, I'd like to say that my friend Antony Nikolaev will speak about his Grinder framework at Bulkhead Asia 2020. I used this framework in my research to grab statistics, but this framework can do a lot of cool things too. Please check it out, and thank you for your attention, and I'm ready to answer the questions.
Okay, thank you, Maria. We've got one question, and that is, has there been any malware seen in the wild that targets vulnerabilities in DICOM?
I didn't scan a world for medical pipelines, medical imaging pipelines, and so I don't know.
Okay, fair enough. One question that I just had was, you showed that the amount of DICOM servers had gone up by to over 2,700, but those are all accessible on the internet. Like showed
yes,
on.
This framework uses a Shodan database for scanning, and it takes all the DICOM servers from Shodan database and rescan this service. And now all 2,700 servers are available on the internet, and also some interesting fact that about 700 of these servers allows to connect to them without any application entity title, and you just you just can go and to take images, and that's it.
Wow. Okay, that sounds bad, but that's just me.
Yes.
The other question I had is, you mentioned an XXE bug, and you contacted the vendor who said, I can't reproduce it on my machine. You could. Was there ever a fix applied where the new updated library was included in that vendor's product?
This version is included in any product? I didn't understand a question.
You mentioned that the libxml from a newer version by default doesn't do XXE anymore. But yes, you did a test and found that, at least from the software itself, no protection is given. So they are, if the XXE is not exploitable, that would be entirely because the library itself doesn't allow it anymore. So my question then is, did the vendor update the library that they ship with the product? Do you know?
Okay. They the okay. Did okay? They update this version, but when they its product is linking with libxml, the version of libxml library is different, and they updated this. On my machine, the version of libxml was newer than on vendor's machine. But on different machines, this product can use different libxml versions.
Oh, right. Yeah, yikes. Okay, so that's all the questions that our lovely people found for you. Thank you very much, Maria, for your talk. The next talk will be in about half an hour, and that will be Igor Lyrchikov and Egor Saltykov with runtime memory analysis for mobile applications. Don't go anywhere. Right, ladies and gentlemen, we will continue with the talk by Igor and Egor. This is another pre-recorded talk, so unfortunately no live Q&A. Possibly you will be able to find them in the Discord channel. I'm not in there, so I cannot verify that for you. I do apologize. The talk that I will be giving is Runtime memory analysis tool for mobile applications, again by Igor Lyrchikov and Egor Saltykov.
Hi, my name is Igor, and today, together with my friend Igor, we will talk about how to make an application in our free time that helps us while working with mobile research. During the talk, we will cover the following topics: Memory 101 on mobile devices, modern approaches to solving our problems that didn't fit us, about how we created the application and what problems we solved along the way, and later how it was packed into a Docker container, trying to make USB ports on different computers together, and other issues, and of course, like, share and contribute on a GitHub.
At first, I want to make a short step back and tell you why we decided to start developing this tool. Memory analysis was a big issue for us, and all current solutions were related to simple static memory dump with a great tool called FreeDump and further analysis on it. Sometimes we do need to check transformations in memory during runtime. So we decided to turn our ugly scripts in a very useful and platform-independent tool. It's really common situation when you are overwhelmed with work and have something to develop which simplify your life, but you couldn't find a free time in your daily routine to build that and continue repeating the same things all the time, isn't it? In conclusion, we took part in Black Hat SG and Div0 hackathon, Hacksmith 3.0, and decided that it's high time to satisfy our internal need, and of course to contribute to the community. Where this tool could be useful? Penetration testers. For sure, it's rather simple when you need to check that confidential data is encrypted in memory and password is not transmitted in plain text, so you can dump and analyze. Then forensic experts. If you do pattern analysis and incident investigation, sometimes everything you need could be loaded in process memory, and sometimes it's in plain text. And last but not least, reverse engineers. It's not a secret that sometimes reverse engineers operate on heavily protected stuff. In this case, you couldn't rely on your static analysis toolkits. And for sure, runtime memory analysis approach won't help you to identify constants which were encrypted or even understand assets flow based on input transformations. Not a killer feature, but sometimes saves a lot of time during mobile app analysis. As I've already mentioned, there are already several approaches to retrieve interesting data from the analyzed application. If memory dump is possible, we can operate on static dump. It's helpful when you have non-modifying datasets and values passed into memory are not changing during program execution. First approach in our list is attaching the debugger. For sure, this method can be applied if there are no protections against debugging. It's a more stable way of analysis and less chaotic than operating on a changing memory in live mode. But if there is good detection implemented, it's likely to cost us a lot of time to bypass. And sometimes it's just an overhead to use the debugger. Next one is static analysis. Definitely there is plenty of static analysis tools which can help you with analysis if there is no protection or obfuscation, but it's still on a different level with dynamic analysis and couldn't be replaced. Certainly those approaches should go together, but in our case we assume that you haven't achieved your target using static analysis. Sometimes we all might experience many analysis complications. For example, SSL pinning, anti-debug, all types of intrusion detection. So, from memory dump, we could retrieve API calls, unencrypted secrets and constants, and if we were lucky enough, encode it during runtime, of course. Android and iOS. Two popular operating systems that power almost all mobile devices on the planet. Android and iOS have its own memory management models. While they have many similar things, with one copying another, the two can be any more different. Not necessarily because one operating system is better or worse than the other, but differences do exist in their memory management. Memory management here means how the two operating systems make the use of their random access memory. RAM can be defined as a way computers and smartphones access stored files. Unlike hard drive, RAM is temporary storage. What this means? Things that are stored inside RAM aren't permanent, like those stored inside hard drives. Since smartphones are devices with a more limited size, there is a small difference between how RAM is used on these devices versus how it's used on computers. The main disadvantage of this Android memory management is the way Google and other developers handle their apps. From the way they are built and created to how they behave in the background. Android uses Java. For good reasons, Java can run on any processor. What this means, it can be ported by many smartphone manufacturers running different hardware configuration. But the disadvantage is that it runs via a virtual machine, which is like a virtual computer layer between the actual hardware and the software. This is a huge disadvantage because a lot of memory is needed to run this virtual machine, and even more memory is needed to store both the Java bytecode and the processor machine code, as well as store the system-needed resources for translating the Java bytecode into the device's processor machine code. Lastly, this virtual machine is built around a method called garbage collection. In short, garbage collection is essentially a way for Android to recycle memory once an Android app is done using it. While this method is effective, it works by consuming much RAM. Otherwise, the system will spend too much time collecting garbage that it will ruin overall performance. Problems can also happen when users have a lot of apps running. Android's original virtual machine, Dalvik, was built in a time where the smartphone industry has yet to know what CPU architecture would dominate the mobile world. At that time, it was designed to use the x86, ARM and MIPS with room to add future architectures as needed. Since 2014, it supports x64 processors. Android devices contain three different types of memory: RAM, ZRAM, and storage. Note that both the CPU and GPU access the same RAM. So, RAM is the fastest type of memory, but it's usually limited in size. High-end devices typically have the largest amounts of RAM. ZRAM is a partition of RAM used for swap space. Everything is compressed when placed into ZRAM and then decompressed when copied out of ZRAM. This portion of memory grows or shrinks in size as pages are moved into or taken out of ZRAM. The storage contains all of the persistent data, such as the file system and the included object code for all apps, libraries, and the platform. Storage has much more capacity than the other two types of memory. On Android, storage isn't used for swap space like it's on other Linux implementations, since frequent writing can cause wear on this memory and shorten the life of the storage medium. If the amount of free memory falls below a certain threshold, the system starts killing processes. To decide which process to kill, LMK uses an out-of-memory score called OMH score to prioritize the running process. Processes with a high score are killed first. Background apps are first to be killed and system processes are the last to be killed. The following table lists the LMK scoring categories from high to low. So items in the highest scoring category in row 1 will be killed first. Android invokes on trim memory method to inform apps that memory pressure is high and apps should deallocate unneeded memory. Android can kill paused apps at any time, so apps should serialize critical state when they transition to a paused state. iPhones have less RAM than Android phones, but Apple has a reason for that. It doesn't need as much. For example, developers of an Android app can make the app to stay persistent in the background. This consumes RAM that otherwise can be used by other apps. The Android operating system that is based on Linux chooses to stop apps running in the background when available RAM runs low. in order to free up for new apps that users are opening. iOS, on the other hand, squeezes more data from apps running in the background compared to Android at a system level. Whereas in iOS devices, Apple has a more controlled strategy. In this case, the operating system chooses whether an app can do something or not when it's running in the background. What this means, iOS allows users to open more apps and having them run in the background longer after users have finished using them. Then, there is iOS that was designed to run Objective-C applications or on known hardware, which is an ARM processor. Because Apple has full control of the hardware, the company could easily make the decision to have native machine code, so it means without virtual machine, running directly on the processor. This practically saves a lot of memory requirement. What's more, iOS doesn't have the garbage collector. Instead, every object created on the operating system has a count associated with it. This is called retain count. A newly created object will be given a count of 1. During the course of the object's life cycle, the retain count can increase or decrease accordingly. But the rule here is that once the retain count reaches 0, the operating system immediately terminates the object. In fact, memory management is simply an exercise in counting. Every object has its own reference count or retain count, which is the number of other objects that are currently using the object. As long as the retain count is greater than 0, the memory manager assumes that someone cares about that object and leaves it alone. When an object's retain count goes to 0, the memory manager knows that no one needs it anymore and sends the object a dialog message. And after that, its memory is returned to the system to be reused. When Apple introduced automatic reference counting, ARC, iOS can automate the process, with the compiler inserting the appropriate retain count to the code before building the binary. This memory management capability is a major advantage over Android's garbage collection. This is, for reasons, part of why iOS devices run so fast while having lower specifications. The following figures show the state transitions involving the app delegate object. After launch, the system puts the app in the inactive or background state, depending on whether the UI is about to appear on screen. When launching the foreground, the system transitions the app to the activate state automatically. After that, the state fluctuates between active and background until the app terminates. When memory pressure is high, iOS forcibly evicts entire apps from memory. iOS finds the application will terminate callback of the about to be evicted app, allowing them to serialize app-specific state before eviction. This state is typically much smaller than the entire working set of the app. Later, when the app is resurrected, it uses the serialized state to reinitialize itself. Application will terminate only invoked on the background apps. Suspended apps and apps that are not running code but have pages in memory is terminated without notification. There are a lot of tools for memory debugging and memory leakage tracing for developers. For iOS, it's via map or tool called Leaks, and for Android, tools like DDMS or any IDEA tool like Eclipse Mat. But these tools are not really useful for our small hacking attempts. While the two operating systems have their own advantages over the other, the RAM usage and management on both operating systems are quite similar and efficient. The main difference is how they manage the RAM in the way they handle apps that run in the background. Fortunately for us, it mostly reflects in memory size we need to process or dump. And here we are happy to have Frida framework to cover ours back.
Let's move on to our history of the instrument, because it was not an instant solution, and the idea has grown and changed several times so far. Starting from last year's fragment of a work task via MVP and the hackathon, and ending with getting rid of unnecessary element along the way of simplification. In this part, we will talk about what stages we went through and how the program changed. Maybe this will give you ideas for your projects, or you can tell us how to improve the current one. The idea to build that tool came up spontaneously when one of us was faced with the task to track data in device memory again, and the classic memory snapshot didn't work as it needs. At the same time, we began to notice that in memory leaked quite a lot of interesting data that is not properly managed by the developers and contained interesting info to research. And friends from the InfoSec community advise us to take part in hackathon organized jointly by GovTech Singapore and Black Hat Asia. That's how we decided to kill two birds with one stone in 48 hours coding run. Of course, they use familiar ways to work with the memory like Frida framework and objection, but some of it did not work as we wanted. There were many flaws with projects that help dump memory, such as free dump, because the application might crash while taking a memory dump. At the same time, this is exactly what is used in objection. However, in a last version, at that time, it became possible to search for a pattern in memory, which interested us. But the main task remained unsolved. We could not track the state of memory throughout the entire application at any given time while looking for a bunch of patterns. We started with a free dump code because it has the functionality of working with raw memory, and it helped us to understand how everything works. Having got an idea of how this works, we turned to the documentation and then found a function that allowed us not to take a snapshot of the memory on the file system, but to look for a necessary pattern directly on the device that gives us a performance boost. At the second stage, we have built our JavaScript file, which could already be run directly from the shell. And we found that many code examples that we encountered on the internet use only the last element of the memory array to look for a pattern in it, thus skipping almost everything else. We fixed it, but it slowed down a little. In any case, even on a big memory sizes, about 1 GB, searching for a pattern takes from a couple to 5-8 seconds, which, in our opinion, is fast. Now, it was necessary to get the opportunity to run this script in the background, and not only on one pattern, but on a dynamic list that could be modified right during the execution. As a result, this was achieved using an endless while loop on Ruby, which from time to time called a new code instance for Frida, and changes to the search array while implementing thought a file socket. In general, this was our main idea, and we reached it by the end of the second day of the hackathon and got the medal. It was decided not to stop because there were many problems. There was no error handler and the correct termination of threads, poorly written spaghetti code, and much more. We began to think about how to improve UI UX and experimented with tons of frameworks and played with input, output, and control interfaces. There was even a web interface. There were also new features popping up while would be useful, and it seemed to us that it would be great. But at one point we realized that we needed not a Swiss knife, but a well-working tool. We came to the fact that we abandoned any kind of interfaces and left only the launch for the shell with several flags. It was decided to wrap everything in Docker. It was a challenge because the devices are connected via USB, but it helped us improve usability. Many algorithms have been rewritten, as well as new functions from Frida to manage memory, and the output has been replaced by structured JSON. Now, everything can be started with one comment, and we can continue to work in a familiar environment, because everything is packed into one Docker container. To more conveniently work with results that can be extensive, an HTML report is automatically generated, and raw data remains if it's integrated into any flows. And we also added static analysis on the memory dump from the device. Here and now, we talk about what was created over several iterations and more than 6 months of work. We are glad to any contributions to the wise or improved code. Also, we have several ideas that we plan to complete in a few months, and you can see them on Black Hat Arsenal at the end of September. We will tell you more about it later. Let me summarize what we have achieved, and we will move on to the equally interesting part about Docker. First, memory tracker with the ability to change the search dictionary without any interruptions during executions. We built an independent task runner layer for control JavaScript Frida, a Docker container with a built-in environment that is ready to work with most iOS and Android devices via USB port, human-friendly report, and raw data for further processing, and of course, macOS Catalina friendly. Now, let's check a little sneak peek.
Let's move to our demo. We will run it against Instagram app installed on iPhone. They've initially pre-generated dictionary with only one word, secret, and later we will add password phrase. We can change it also dynamically, because after one iteration, it will back to this dictionary and we read it again. So we can see it generates the output HTML file with lots of data and links to physical files. And it's also created JSON raw data, which can be easily parsed with different applications. Now let's move to static mode. It's run several tools one by one. Initially, it will dump info from memory device and put it in a dictionary dump test. And later, the application called SignSearch
will be run against this dump, which helps us to find some patterns already used in this dump and memory, which might be leaked. And it also generates some file. We can use it later to our next steps. It is important to note that during our work, we noticed that all the examples that used memory scan to walk around in memory in search of a pattern used only the last element of array. Therefore, it works quickly, but skips of other sections available for working with. We slightly changed the rules of walking across the memory list, which caused a slight increase in operating time, about 2 seconds. But we began to find more occurrences of a pattern which improved the result.
Now it's time to say about our environment. During many rounds of modifications on our tool, we noticed that it's always a huge mess to configure the environment for testing. This problem is applicable in the case of many other open source tools when it's not possible to test on all ecosystems. Docker really makes it easier to create, deploy, and run applications by using containers. And containers allow us to package up an application with all of the parts it needs and ship it all out as one package. By doing so, we can be assured that the application will run on any other machine. When we started testing how it's going to work inside a Docker, we stumbled upon a few issues for us. First, we was not sure if it's going to work since there were no clear solution on USB port forwarding from Mac machine to Docker container. After short lookup in this area, we found that it could be done using Docker machine, which is part of Docker setup based on VirtualBox image. Second issue was to set up all the necessary SDK packages and supportive libraries for both Android and iOS for correct interaction with them as smartphones. When it was done and devices recognized, it was a time to start having fun and rewrite our Frankenstein one more time. List of advantages was pretty huge for us. At first, it gave us a platform-independent solution, which is easy to implement in the automation pipeline. Users don't care anymore about configuring virtual environment for Python, then a VM for correct version of Ruby, and other related stuff. It became easier for us to deliver updates. Also, it was useful to keep different versions of Docker images for different tasks. Because of the nature of our tool, as a pet project, sometimes we don't have enough time to enlarge current functionality, but it takes only a few hours or even minutes to rewrite the logic on top of Frida and spawn a new Docker image based on a previous one. Now it's time to say about some disadvantages. In my opinion, it's a little of a pain to make initial setup if you're on Mac. Because you need to install a VirtualBox and configure Docker machine, which is not a straightforward process at the first sight. Since we did this process a few times during testing of our solution, I prepared a short guide on step-by-step setup. Currently, it's for Mac OS users only, but we'll extend it for other platforms a bit later. On Linux, it should be way easier to set up, and Windows users should expect the same amount of pain. However, it was never tested on Windows machines, actually. And yes, you can find this guide on my GitHub account page, which is on this slide. Let's move on and see the demo part. We'll start with Android device, and in our Docker container you need to plug in your Android. So in our case it's Nexus 6P, and as you can see, LS USB output shows that it found. And after you entered ADB devices command, you should approve ADB debugging on your device itself. Then make sure that FreeDE server is up and waiting for incoming connection. Then you can launch our MemoYop tool with a bundle ID as a parameter and -d mean dynamic mode. And now we are seeking for our secret value, which is entered in a password field. And as part of application logic, it probably purged from memory. So if you make a static dump, it's a big chance that this value won't appear after static dump. But since our tool is working in a multi-threading mode, it's trying to capture the interesting values during different states of execution. So we'll see how it's gonna look after we give some time to finish our tool working. As we can see, there is no new data in memory, so we can safely shut down our process. And now let's check it inside the Docker container itself without any beautification. And as you can see, in a deleted region of Delvik main space, there is our confidential value, and it means we are good in this case. And in a real world scenario, as we can see, the nearby string, it's like string entered. So we can try to look for this value next time and suppose to have a password next to it. Now let's check the same routine with iOS. So make sure your iPhone connected. Then we check if USB maxed process is up. So it means our Docker container is marked as trusted computer for our iPhone. Then we just grab the value of our testing application, and in iOS case we are using the app name as a parameter and -d for to enable dynamic mode. And here we are seeking for one really secret value that's supposed to be recovered from this sample app, and part of the phone that we'll manually enter later, and username value just to check what we could grab from the memory. Maybe there is some hard-coded values. Then you can continue using your application or just give it a time to finish execution and memory analysis. As we can see, there is no new data in memory. And it's safe to shut down the process. The same thing, we can open the log manually. So we can see our entered phone value and the secret value that's supposed to be recovered using any other method. And since our pattern for phone matching was a pretty dump, I would say, there is a lot of wrong results and false positives. So this part is to be optimized in the future. And as you can see, there is also some static assets recovered from the memory. Fortunately, we can filter it using this path value. We can define if it's from real volatile memory or it's a just static asset loaded into it. So, as I already mentioned, our tool is to be updated in the future, and we'll try to provide many other options of using it. Our next updates will be focused on beautifying the output and make runtime dump chunk size more flexible. Of course, we are open to hearing from you which options could be useful in your working scenarios, because today we are modifying workflow manually for each of our tasks and executing it from separate Docker container. So, as I already said, any suggestions and ideas about collaboration are very welcome.
That's all for today. New updates will be shown at Black Hat Asia Arsenal 2020 in September, if nothing is cancelled. This tool is a very young project, with a huge backlog, with improvements that are rolling in production very slowly, since it's developing only on weekends. We hope that going public that this project will help us to hear your needs and make tool a better version of itself, with help of open source community. We are going to add some features later, like Docker Linux support and more real-life use cases. We will also be happy to hear any feedback on where you found tool to be used. Thank you. Now, if you have questions, do not hesitate to ask it. On the screen, you also see two links with Docker image and standalone tool.
And that concludes that talk. As I mentioned at the start, this was pre-recorded, so we cannot do live Q&A, but I have it on fairly good authority that at least Egor is on our Discord channel. So should you have any questions, join that, and I'm sure he will be happy to see you and answer your questions. We are now heading for a break, and after the break is done, the next talk is going to be by Operation SemiChimera, APT operation targets semiconductor vendors. That will be by Bletchley Chen, Inndy Lin, and SHANG-DE Jiang. Have a lovely dinner, or if you're in Europe, lunch, and I hope to see you in about an hour.
should go to another planet because Earth is kind of strange.
Right. Good evening, everybody, and happy to see you all return at this hour. We are going to continue with the evening program for this HITB Lockdown 2nd edition. The first talk of this set is a pre-recorded session. The subsequent talks will all be live, but this one is pre-recorded, so unfortunately for questions you're going to have to resort to Discord. I have been reliably informed that our speakers are in fact currently in Discord already, so if you have questions just ask them there and they will see to it that you will get a nice answer. Next talk, as you can see here on the screen, is Operation SemiChimera, APT operation targets semiconductor vendors. This is a talk by Bletchley Chen, Inndy Lin, and SHANG-DE Jiang.
Hello everyone. We are happy to come here for sharing our research. I'm CK Bletchley Chen. I and my colleague Inndy and Jiang will share our research. Chimera APT group targets Taiwan semiconductor vendors. So first, let me introduce ourselves. I'm Zhongquan Chen. You can just call me CK. And my Twitter ID is Bletchley13. I'm a security researcher. After I get my PhD degree from National Jiao University, I joined the SciCraft as a senior researcher. And when in university, I have published some research in academic conference. And I also published some research in a technical conference like the Hijacking, VSCon, RuCon, First, and CodeBlue Open Talk. I'm also a retired CTF player. I'm a founder of Bamboo Fox CTF team in National Jiao University. And I also have experience to join the DEFCON final CTF in 2016 and 2018. I also lead our students to join some bug bounty program and discover some vulnerabilities in QNAP and Synergy. I'm also an active member in Taiwan's security community. I'm a member of CHRoot, which is the best hacker group in Taiwan. And this year, HICOM 2020, I will be a chairman of HICOM editorial committee. And my partner, John, he is a security researcher in SciCraft and also have published his research in HICOM. And he also founded a Taiwan local hacker group, UCCU Hacker. And Inndy Lin, he is also the researcher, security researcher at SciCraft, and mainly focus on malware analysis and detection. And he also have shared his research in HICOM and RuCon, and often give the training in local security community. He is a reverse engineering hobbyist. And from his high school, he started to learn reverse engineering for game hacking and CTF. So we also introduced our company, SciCraft. SciCraft is a startup company in Taiwan, which is just moved to its third year after its startup. And our company focuses on using AI to help solving the security problem. Currently, we have three products. The first one is Zenser, which is used for threat hunting, and Sakura, which is used for APT investigation, and CyberTotal is a threat intelligence platform. With the help of this system, we can quickly analyze and analyze the APT campaign. So today our talk is a lot helped by these products. And our company also joined the MITRE ATT-CK evaluation in last year and competing with many top security vendors in the world and get a very nice result. If you are interested about it, you can reference to our public report in our blog. This is today's online. We will first give the introduction about Taiwan's semiconductor industry, and then we will illustrate the APT group Chimera that we discovered in these 2 years. And then we will go through the case study to understand the activities of threat actors. And then we'll go deeper to see the threat actors' digital arsenal, which introduce the malware and technical used by attacker. And then we will make the conclusion. Because Taiwan has a very special political position, so we always being attacked every year. In 2018, the TSMC, one of the largest semiconductor vendors in Taiwan or even the world, is attacked by ransomware WannaCry. This attack held down their production line for 2 days and make the cost about 170 million. In 2019, Kaspersky has discovered the Shadow Hammer, which is a supply chain attack targeting ASUS. And in this year, our critical infrastructure is being attacked by the Colock ransomware. The CPC is an energy sector, and who has a lot of gas station. So in this attack, a lot of the gas station is out of service and make many inconvenient and economy cost to Taiwan. Among this industry, I think the semiconductor vendor is most important to Taiwan. And many people will say that the semiconductor is most important industry in Taiwan. That's because our government has paid a lot of resources to develop and help these vendors. And now Taiwan has already established ourselves as a leading player in this industry. And we have some well-known leaders, include TSMC and MTK. In 2018, our wafer capacity is to take the first place in the world. And in 2019, our market sharing is take the fourth place in the world. According to Taiwan's news, we are the largest and fast-growing semiconductor equipment maker and make the revenue about 12 million. All of this show that Taiwan takes a very important role in the semiconductor landscape. So once the attack to Taiwan's semiconductor vendors happen, it will make a very serious impact, like the TSMC ransomware. So first, because this vendor take a lot of part in Taiwan's economy, so the attack to this vendor will of course make a serious impact to Taiwan's economy. And in the same time, it will also affect the entire global supply chain. Even though many research about this area will focus on the OT security, but in this report, we want to remind that IT attacks can be as dangerous as the OT attacks. In the attack to OT, for example, they may make your production line halt, and make it immediately damage. And compared to that, the attack to IT, for example, leaks some important intelligence property. Even so, you will not immediately identify the damage, but it will have a long-term impact to the enterprise. So both the OT attack and IT attacks should be taken care and has equally important. As SciCraft is a Taiwan local security company, so we have a very high visibility in semiconductor vendors in Taiwan. And between the 2018 and 2019, we have monitored several attacks on these vendors. And mostly victims are located at the Hsinchu Science Park. And Hsinchu Science Park is a center of Taiwan's high-tech industry, especially for the semiconductor vendors. And we have published our first version of the report in April this year. And after we published our report, we received a lot of feedback from other security researcher, other vendors, and our cooperation partner and our friend, and revealed that more than 7 vendors were targeted by the same threat actor. So I would say that this attack is very intensive. The threat actor have the ability to launch a large-scale attack to many vendors at the same time. And the other noticeable point is that the attacker had a very in-depth understanding of the semiconductor industry. This attack is not choose their victim randomly, but their attack is very precise and well coordinated. Aside from the vendor themselves, their subsidiaries, competitor, and cooperation vendors in the supply chain will also be targeted. So I would say that the APT attack is from the past, which only attacked a single enterprise, a single point attack, to attack the supply chain. Now they are attacking on the entire industry surface. As the activities, attack technique, and tactics were very similar, so what we believe this was the work of the same threat actor. And we call this threat actor the group Chimera. They are targeting the security vendors in Taiwan, and then use some malware which is merged from different open source or commercial product. In our case, we discovered Dumper, Mimikatz, and Copperstrike. So that's why we named it Chimera. Just like the Chimera is a merge of a different animal. Their malware is merged from the several open source malware. And in order to avoid attribution, their C2 is hosted in public cloud, like the Google App Engine and Azure. And their goal is mostly focused on intelligent properties. They try to steal document, source code, SDK of some projects related to chip. So from here, we can understand the motivation of the attacker. Here is our investigation overview. Our investigation period is in 2018 to 2019. And we investigate more than 3 vendors and analyze totally more than 30,000 endpoints. In today, we will share you 2 case studies. Why we choose these 2 vendors? The first reason is that these 2 vendors take a leading global position in their market segment. And the second reason is that because we get into investigation at a different timing. So an analytical perspective of the tech campaign was also different. For A company, he is our long-term partner. So we regularly monitor their activities, which allow us to find more detail of the attacker's activities. And this information also enables us to track back to the root cause. So in the case study of A company, we want to show you the activities of hackers and the root cause, how to track in the root cause. In the case study of a B company, it's a one-time IR service. So when we start the investigation, the attack is already happened for a long time. So we cannot recover everything back. But what we have is that we can monitor and identify the long-term activities of the threat actors. And we identify what kind of data, what kind of file was stolen by the attacker. So what data was leaked in this case. So next, we will turn to our analyst, Jiang, to share these 2 case studies.
Okay, thanks to CK. So I'm Jiang, and I will next present about the 2 case study. And before we start the case study, I just want to mention the following slide, and every machine and the username are the identifier, and these are not the original name. And the first technology we want to use is the accompanying. So following is the accompanying status overview. So accompanying is our long-term partner. So the thread editor activity date is very short time with discovery and stop. And we found that 15 endpoint and 6 user count were compromised. And we found 4 malware and 8 C2 server. And we will introduce on the C2 server and the malware later on. And the right hand side is our NI generate investigation graph about tell us what endpoint has been compromised and the compromised endpoint how to when the lateral movement to the another endpoint and the dropper which malware. So it's a simple timeline to help investigator to understand what happened on this environment. And the first malware we found is the Cobalt beacon. Cobalt beacon, the threat actor uses Cobalt beacon and pretend as a Google update. And the Cobalt beacon also will migrate the payload into the other process. The first, we found the Cobalt beacon, we searched on the files total, and we found nothing. And the SQLite means the threat actor possibly customize their different malware backdoor for the different user and the account, and the endpoint. So we found the 2 different file hash in the 2 endpoints. And the Cobalt beacon has a user hosting service for their C2 communication. So these are hard to identify for the network security device, and because they use Google pretend as a Google update, and they connect to a Google Cloud service. So it's feels like a reasonable, very logical. But it's an interesting point is about the first day the threat actor use a Google Cloud platform, but the second day after they get the new endpoint, they switch the hosting server. This is quite interesting. About in our investigator point of view, we think because the threat actor is a team, so every operator has their different they prefer use the different hosting server and the hosting service. So they switch the hosting service to another provider. And we found PC China is deployed from the server Lauren. So how they deploy is they use a schedule task, and there's a task time is before the employee get off work. So because they pretend as a Google update, and even they trigger the security alert, maybe they will handle the security event tomorrow because there's a Google update. Maybe the binary has an update, so trigger the first party for the antivirus. So there's a reason they execute the attack before the get off work. And then we trace back to the server Lauren. So we found there's a tool remote execution tool in the server Lauren. So they use a benign program like the schedule tasker and the WNIC. So the schedule tasker actually use in a multiple endpoint, and the reason they use a schedule tasker not just for the persistence, they use a schedule tasker just for the execution, and they also use a WNIC. But there's an interesting point about why the threat actor use a WNIC and a schedule tasker. Why they just choose one tool? Why they use a multiple tool? The reason they use WNIC and the SQLite is WNIC can use the WNIC can use a cache credential. And the second is WNIC can get STD out information. So in this thread, they use WNIC to check the network communication, check the endpoint can has a network communication to the internet. And they use a SQLite to deploy their malware. And we trace back to the server, so we can, due to the previous finding, we can add to the information to server has later moved to the 3 endpoint. And we found the server has remotely collect the registry and the NTDS.dat in the server, in the domain controller. And they use archive tool. The archive tool is renamed as recordtv.ms. So they collect these two files, registry and the NTDS.dat. So why? So I will quickly explain the NTDS.dat. NTDS.dat is Windows AD data, which it contains the Windows AD username, password, email account, something like this, all the useful information in the AD environment. But the database is encrypted. So the encrypted key is stored in the registry. So that's why the reason the thread need to collect the registry and the NTDS.data file. So the thread already collect the AD database. And why the server has this kind of malicious activity? So our NI investigation tell us there's before the attack start, there's a umbiculaire schedule task deploy the cobalt drive beacon to a server login. So as you can see the screenshot, there's a schedule task to the server login and use Google Update pretend as use cobalt strike and pretend as Google Update. And there is a one-time execution and it start at the 1958. So we trace back to the umbiculaire. So in the umbiculaire timeline, we discover the schedule were executed in 1958. But the command has been executed is just before the 6 minutes ago before the 1958. So we checked the timeline. We found there's before the command execute, there's IP1 has a RDP to umbiculaire. So this is highly suspicious the root cause of this attack. So after the thread add RDP to the umbiculaire, they use the anti-user to do some reconnaissance about the user information because the environment username are serialized, so they can enumerate the environment domain account to get some information, and they store the information on the recordtv.lib.log. So after they collect this data and they use the recordtv.ms to do the data extraction. So they use a 1-byte modifier WinIR software and rename as the recordtv.ms and the uncheck.dmp and the jucheck.exe pertain as the Legezo software. And the same file has been found in the other endpoint. So based on the previous technique and the Legezo software, the install, we think this signature technique about our report operation Chimera. And we check back into the who RTP, the MB layer. So we found this IP1, and IP1 is on scan host and relate to the many user count in the whole environment. So we check into the IP1. So we found there's a share host, and actually it's a VPN host. So VPN host can be compromised. So in our opinions, we think never use a VPN as the only line of your defense. These both are the first case study, and I will introduce a second case study about the becoming. And the becoming is an IR case, and I just want to quick overview about why we do the IR case about the becoming. Because becoming already been compromised, but they don't know. And becoming has a big business collaboration with C company. And the C company is our friend. And due to the business collaboration, becoming and C company has a network communication. And the C company security discovers some anomaly activity from becoming. So C company introduced us to the help investigation on the B company. So becoming has been hacked starting the 2018 and until the 2019. And we look into the 140,000 event, and we found 40 compromised endpoint and a lot of the data leak. And the becoming case study, we didn't find a Google update, but we found a lesser PowerShell attack. And they use the PowerShell attack as they use the PowerShell script and execute the COBOL strike beacon and migrate to the SVC host. And we found this PowerShell attack on the 10 endpoints and crossing and include the 2 domain controller. And just like a first case study, the C2 communication is used hosting server. So like the Google Cloud Platform, and also in this case study, you also use Microsoft Azure. So it's hard to track down the threat actor. Just like we previously mentioned, the becoming already has a serious hack. So the human investigation is hard to address what endpoint has been compromised. So we use our AI investigator to help us to figure out what happened in the environment. And we also, so this graph is our AI generate. And this graph also tells us the domain controller already has been compromised, and the domain controller also connect to this unmanaged endpoint. It means we didn't scan the endpoint. So it tells us our investigator to need to do some investigation about this endpoint to check the compromise scope. And because the threat starting the 2018, they already has a compromised becoming. And they come back every quarterly to get some new file, new information on the big company. And but the compromise scope didn't extend until 2019 November. The threat actor deployed a new weapon we call scan turnkey injector. And after the scan injector deployed, the threat actor has extended their compromise scope. So it means the scan injector is works for them to get the environment. So our colleague will introduce the malware part in next on later on. And we found in the first case study and the second case study, the threat actor use a similar password schema to archive their the IR file, and they pretend the WinIR software as a record TV, JU check, firmware.log, something like digital file name. And the threat actor has collected the leak file name. Has collected a leak file, which we de-identify, and just like they collect the project roadmap and the backup workspace and the chip and SDK information and the installation guide. So our assumption is the threat actor is not just for cracking the environment. They are doing this stealing the intelligence property. So we think the threat actor is possibly is a business spy or state sponsor attack to benefit some country want to benefit their certain industry. So we are not sure which one, but we can feel sure is the threat actor target is not it's just for the stealing the intelligence property. So the target very straightforward. So this my part to the case study, and I will to turn to our next presenter, Inndy. So that's all.
Hi, I'm Inndy, reverse engineer from SciCraft. I'm going to introduce the actor's digital arsenal. We want to share 3 main tools they used to carry out this attack. The first we are going to talk about is Cobalt Strike. Cobalt Strike is a commercial red team operation framework. They use Cobalt Strike beacon as their primary backdoor in these intrusions. For the persistency, they override Google Chrome update utility with their Cobalt Strike beacon. Thus, there is no any new auto-run entry was created, so it will lower the chance to be caught. We found this backdoor on several companies, so we link the intrusions events together. Cobalt Strike has 2 components, Stager and Beacon. Stager is a little shellcode that can load another payload. It will be useful if the payload size was limited, or you don't want to deploy entire backdoor to the victim. Beacon is the full function backdoor. Just like any other backdoor, it has capability to transfer files, set up tunnel, code execution, and others. Our product detected some suspicious memory block which contains a Cobalt Strike beacon. As you can see on the slide, it is a PE file and a shellcode payload. So, Cobalt Strike beacon and Metasploit interpreter both use this technique, the hybrid payload. This technique is to embed shellcode into the PE file header. The PE magic header, MZ, could be decoded as valid instructions. It will be decoded as POP R10 under 64-bit architecture, and decrease EBP POP EDX under 32-bit architecture. These instructions will work fine in most of contexts, so you can ignore these instructions and append shellcode after it. The shellcode will locate its address and execute the reflective loader to load PE image in memory. It is this assembly output of Stager. There are 2 types of Stager. One uses name pipe. Another uses WinHTTP library. So, Stager could be used to download payload from remote server, or being used during process migration. Cobalt Strike uses a special strategy to inject payload into other process. First, Cobalt Strike will spawn a new process or choose an existing process as target. Then, it will inject the shellcode into the target process. We call the shellcode stager. The real payload will be transferred through named pipe and then executed by stager. This strategy will bypass some sandbox or emulation-based scanning. Here is the WinRAR. It is a popular compression software. It was used in this operation. The actor uses rar.exe to compress and encrypt the files list down. They try to ambiguate the program with existing path recorded tv.library-ms in the same folder. The reason why we mention this file is different from the original one. So we grab this old version of WinRAR and compare it with the one that actor used. We found the difference part was located in code section, and such patch may crash the program. We have two hypotheses. First is the actor changed the byte to make file hash different. So hash-based detection will not find that file is rar.exe. If your organization do not use WinRAR, the file may be detected and trigger some investigation. The second hypothesis, it was uploaded to VirusTotal in 2009. We think it is just a bit flip during copy judged by the file age. It is highly possible at that time. Now we are going to talk about the most interesting malware used in this operation, the skeleton key injector. We found a unique malware that made with two open source hacking tools, Dumpert and Mimikatz. I believe everyone here had heard about Mimikatz. It is a well-known hacking tool to dump credentials from lsource.exe memory. But it has more capability like bypass group policy and spawn command line prompt, task manager, or registry editor. This malware has been found on at least 10 domain controllers. So, that we found bunches of forwarded import entry and indicates that it is a DLL proxy. Actor exploits DLL hijacking vulnerability to persist and escalate privileges. Maybe you don't know this hacking tool. Dumpert is made by the security company called Outblank. It is a proof of concept program to use direct system call on Windows. Unlike Linux, we can't directly use system call in shellcode because Windows system call numbers changed from release to release. The only stable interface is exported function from the shell libraries. That's why Windows shellcode must rely on them, and always begins with locating functions in memory by traverse PEB, loaded data, and PE structures. So, how do Dumpert doing it? First, it uses RTL get version to determine Windows version, and select different embedded shellcode, embedded system call functions depending on the Windows version. After that, you can bypass any user space hook and doing anything you want without trigger alert or get blocked. And here is a code shows that how does Dumpert embed system call in its body. It will choose the different embedded system call functions. For the one who don't know what skeleton key is, skeleton key is an APT malware discovered by Dell SecureWorks in 2015. it will implant a backdoor password to a domain controller in an Active Directory environment. Then, attacker can authenticate as any user as they want with the backdoor password. Meanwhile, original password was never affected. Any other wrong password still will be rejected. So, how does skeleton key implemented? It will alter the authentication flow by hooking some crypto functions in lsas.exe, more specifically in KDC service, the key distribution service. Although original skeleton key malware was never released publicly, author of Mimikatz still made his own implementation. The actor made skeleton key injector by merging Dumpert and Mimikatz. They copied necessary code from Dumpert and Mimikatz, then modified functions in Mimikatz to use embedded system call functions from Dumpert. So, if your protection product did not use mini filter driver, which means did not put a hook in kernel space, the skeleton key will be invisible. Skeleton key is a very powerful weapon against Active Directory because you don't need to dump administrator credentials for lateral movements. If you use administrator credential to access endpoints in a domain, you may trigger a lot of alerts. But if you log in with normal users, the situation will be different. It leaves nearly no clue, only bunches of logon success events. Most administrator or investigator will ignore normal user logon events easily. And skeleton key cannot be removed easily without reboot. It will be painful to reboot all your domain controllers because you may break your organization's daily routine. Now, CK will make a conclusion for us about this talk.
Finally, let me give some conclusion about our research. So here is some takeaway. In this report, we disclosed a large-scale APT attacks targeting semiconductor vendors, and more than 7 vendors were compromised. And this attack is a precisely attack and targeting leading semiconductor vendors, and also attack their subsidiaries, partners, and competitors. And their goal is stealing intelligent properties, document, source code, and SDK, which will make a long-term damage to the victim. In the technical part, the attacker utilized various open source and general tools to make the attribution harder, and they will merge the different kind of malware and insert their customized code to make their own malware. In the 2 case study we are shared, the AD and VPN was compromised, which show that enterprise should consider the resilience of their IT system and avoid to relying on a single security service. And the technical skeleton key is used in this case, and this technical is rarely used in the past. However, it's a powerful weapon which can make adversaries log in like a normal user for the purpose of persistent and defense evasion. In the end, there are no systems safe. We should regularly do the threat hunting and shorten the mean time to detect and mean time to response. So thank you for your listening. And if you have any question, welcome to ask your questions on Discord. Thank you again.
And there you have it. As they said, any questions, please bring them to Discord. Our next speaker here will be in 15 minutes. It will be Joe Gray with his talk, A Decepticon and Autobot Walk into a Bar, Python for Enhanced OPSEC. Don't go anywhere. Right, welcome back everybody. We are quickly continuing with our next talk. That is Joe Gray with his talk, a Decepticon, an Autobot walk into a bar, Python for enhanced OPSEC. Joe, take it away.
Thank you, and welcome to a Decepticon and Autobot walk into a bar. This is a new Python tool for enhanced OPSEC. I'm Joe Gray. I'm alive. I'm doing well. I hope everyone else is doing well. So I just wanted to have the camera on for just a second to demonstrate that I am a live human being. So I'm going to go ahead and kill the camera feed and go ahead and get started with the presentation. So about me by day, I'm a senior OSINT specialist at Complex. Prior to this, I had some experience with Python scripting, but I would by no means call myself a guru, a master, or really anything above slightly competent. One thing I am incredibly interested in is data science, so things dealing with machine learning and specifically natural language processing. And I've been looking for applications for both of those disciplines and how to incorporate that into OSINT as well as OPSEC. And then if that worked out, my plan was and still is now to find a way to branch that into social engineering in some form or fashion. Also about me, I'm a frequent competitor in the Tracelabs Missing Persons OSINT Search Party CTFs. At the last global competition, my team, the Password Inspection Agency, got second place out of 190 teams. If you haven't picked up already, I'm very passionate about OSINT and OPSEC. I also have a DerbyCon black badge for winning the social engineering Capture the Flag in 2017. And I have advisory roles in a volunteer capacity with both the National Child Protection Task Force and Operation Safe Escape. Operation Safe Escape on this slide is put in bold because at the end of the day, this tool is something that as I was writing it, it became apparent that it's something that they very easily could make use of for a positive impact in the community and with those people that they call clients. I'm not a programmer or developer, nor am I a mathematician or a data scientist. And honestly, I'm not even an expert when it comes to trafficking and domestic violence and that kind of stuff. These are all things that I'm interested in. And the first two are things that I want to get better at. The third one is something I would like to become more knowledgeable about to the point of making those things go away. That being said, there's a few definitions that I'm going to be tossing around today just to make sure that we're on an even playing field. The first one will be OSINT, which is open source intelligence. Basically, that's information that we get from public sources, oftentimes nearly spoon-fed to us by the subject of the OSINT investigation. It differs from a lot of the other INTs, so things like electronic intelligence, signals intelligence, humans intelligence, because we're not really having to hack anything as if we would with signals or electronic intelligence. We're not having to use any advanced techniques of that nature, but we are collecting information in an intelligence context. Next, we have operation security, OPSEC. You may also hear this referred to as PERSEC for personal security, but basically it is making it hard for people to understand what it is that you are actually doing. If you are on vacation in, say, Australia, then you may be scheduling posts to make it appear as if you are still in the office at home or something to that effect. So it's just a matter of making it difficult for an adversary to find out enough about you to be able to cause any form of harm. Decepticon in itself is a term that I've been using over the past few years when presenting at various conferences about using disinformation and deception for the purpose of OPSEC. Now we're going to go into what I like to call vendor land, which these are words that, just like the word cybersecurity, vendors are kind of abusing at times. So to provide the definitions that I'm operating off of, machine learning, basically that's just the study of the algorithms via learning, meaning that there's some level of memory and carryover from one model to another that allows it to influence predictions and decision making. Data science is basically the study of all things associated with that, several disciplines involved so that we can gain insight from that. Artificial intelligence, basically, it's looking for, air quotes, intelligence so that we can attempt to mimic the natural intelligence of humans or animals so that we can reach our desired outcomes and possibly even attain cognition. Then the final part is a GPU, graphics processing unit. Basically, it is a specialized system primarily built with the purpose of processing images and video, but it is also commonly used in machine learning to speed up processing. By comparison, a lot of CPUs have DDR4 RAM on the motherboard, whereas GPUs are running with DDR6. And then in the GPU ecosystem, they have a certain amount of CUDA cores that allow more efficient processing than what you would get out of a regular CPU. So as we go through this, the problem that this presentation is trying to solve is basically one of the leading ways that adversaries find their ways into the lives of their victims is via social media. And when I say adversary, that could mean abuser, that could mean someone who's just a nefarious actor trying to seek harm to a victim, whether that be through abuse, trafficking, could be political opponents, it could be nation state parties, it could just be threat actors groups. There could be a financial gain incentive for this, or it might just be the product of poor mental health in cases as well. But nevertheless, there's a variety of reasons and ways that this could go about happening. And then, of course, we have the adversaries of opportunity. That's the type of person who gets a brand new credit card, takes a picture holding it up, saying, hey, look, I got a brand new credit card. And then someone's like, I don't think that's real. Show me the back of it. And of course, here comes the next picture that shows the CVV of the card number. And then, well, they're maxed out at their limit very quickly. And that would be considered an adversary of opportunity, either through being tricked, unaware, or deceived into potentially, actually, that's victims of opportunity. The adversaries of opportunity are the people who capitalize on those situations. And the adversaries of opportunity tend to go after that final bullet, which would be people with poor or misguided OPSEC. I was having a conversation with someone I served with in the Navy recently, and it was about the TikTok stuff with them phoning home information and collecting information from the clipboard and other things. And he's like, I don't have anything to worry about. I use a VPN. And that led to a conversation about free versus paid VPNs, and not all VPNs are created the same and all of that kind of stuff. And then he's like, well, I use this particular other service. It's not Quad 9, but it's something similar to Quad 9. I was like, well, that doesn't really accomplish what you think it does. Here's what it really does. He's like, all this time I've been searching for this stuff and I didn't think anybody could see it. Well, it's a good thing we had this conversation. But as we look at other victims, that could be politicians, executives, other public figures, and then, of course, the victims of domestic violence and trafficking. So dissecting some of this possible advice that we may receive from an OPSEC perspective. Honestly, abandoning the account is probably, in many cases, especially when dealing with domestic assault, that is probably the best option, but it's not always feasible because the adversary may pick up on the fact that this account is no more. And if the person is using another social media account, that adversary could go find that account and continue their path of destruction. Keeping in mind that some people have to use social media for work. For me doing OSINT, I have to use social media for work. Fortunately for me, though, I don't have to post anything to social media for work. I just have to have access to look at other people's social media. But if someone's in marketing or sales, maybe even HR or recruiting, they may have to use that social media. And honestly, it begs the question, why should someone have to live in fear and tiptoe around someone else? And, the answer to that is Decepticon, really. But at the same time, some victims, they don't even know that something's happening until it's too late. So as we dissect this a little bit more, some of the other wisdom that I've heard is, well, just block the abuser. Well, the problem with that is the abuser can create fake accounts. Depending on some of your access controls, you may have things set to friends of friends. Especially if you were in a relationship with someone for any period of time, you are going to have the possibility of mutual friends. And then you also have to worry about if the adversary finds any alternate accounts that you are using that's not the one that they are aware of, they could report that for being fake. And given right now with COVID, Facebook's not doing a whole lot about fake accounts, but if they reported enough from enough accounts, eventually something may happen and you may be prompted for a driver's license number or another form of identification. They can still attempt to reset your password, whether that be successful or not. And then looking at this from like the perspective of an executive, even if you block an adversary as an executive, they can still target your company. And from a realistic perspective, as an OSINT investigator, I'm honestly more skeptical of a subject that I look at that doesn't have any social media presence, more so than any that I look at that has something. Even if it's just a Facebook that everything's set to friends, or they just never post, they have one picture and nothing else, that's not out of the ordinary. Having someone that has absolutely no presence, but everything else within their dossier lines up for that, that certainly does set off some alarms. So honestly, it begs the question that I've got here on the slide. Why do we not have autonomy and agency over what is posted with minimal effort? Well, at that rate, enter Decepticon. So regarding the code, here's links to the code. Basically, they're the same link. It's just one's going to get you there a little bit easier than others. I'll give you a moment for that. And then I'll explain the code, explain how the code is built, do the demo, and then work through some lessons learned and what have you. So the code is written in Python. Right now I have two versions. Only one is up on GitHub. One version, the version on GitHub, leverages TensorFlow and Keras. Basically, I'm using the NVIDIA port of TensorFlow version 2.20. I've got a link for instructions to install that on the repo, because this is optimized for the NVIDIA Jetson platform right now. I'll explain that in a moment as well. I did some parallel research with PyTorch. I like PyTorch's efficiency with everything, but I wasn't able to get the accuracy that, and I'm going to use air quotes here, the accuracy that I have with TensorFlow. I wasn't able to replicate that with PyTorch yet. So that's something I'm working on. I use pandas to organize the data into data frames. So basically think of that as kind of like a CSV file or a spreadsheet in memory. If you view a data frame in something like Jupyter Notebook, then it actually looks just like a spreadsheet. But within this, I use Keras to implement the long short-term memory model. And that's what is actually used to analyze and generate the text. So what's a long short-term memory model? Well, it's a type of recurrent neural network. Well, if you're not familiar with that, what's a recurrent neural network? Basically, it takes into account past decisions and how those decisions worked out to influence the outcome. So if it learns something, it has the capability to remember that, depending on how it's stored. And unlike traditional neural networks, they don't have a fixed vector size. And that's very useful when we are talking about natural language. Even though this is pulling from Twitter, we can't say that we have 200 inputs with a vector of 280 characters, because not every single tweet has 280 characters unless we explicitly make it do that. So having a vector size that is flexible works very well for things dealing with natural language, which would include text and speech. And then it's also commonly used in images. So the LSTM learns order dependencies and does the sequence prediction. So that's looking for characteristics associated with the language that you're speaking. So in the English language, if a word ends in Y, we typically pluralize it as ending in IES. There are exceptions to everything. And then if a word starts with a vowel, we usually predicate that with the word an as opposed to a. There are exceptions there as well, but LSTM is going to look for those types of dependencies and perform that type of sequence prediction. So how does the code actually work? Basically, we start with Twitter API keys, and I used the Python Twitter package. There are other packages out there to use if you want to try to replicate this with your own coding set. But I just chose that one. It's very easy to work with. We pull down the tweets. As it is scripted, it will pull down 200 tweets. It'll take a moment to do that because it sleeps on rate limiting. Twitter does have a rate limit on that. If you don't sleep on the rate limit, you're only going to be able to pull down 32 tweets at a time. It's going to read the tweets. By default, the code that's on GitHub only reads the tweets of the owner of the API key. I'm going to be releasing probably, I'm going to say August 1st or that ballpark. I'm going to be releasing a version where you input accounts that you want to mimic so that you can basically use it to manage SOC accounts, so fake accounts that you might use for OSINT purposes or research purposes. From there, we capture the text and the time of the tweet. We convert the time to epoch time so that we can do linear math with it, as opposed to having to count on our fingers and toes days, minutes, and seconds. We also capture what I called lexical diversity, and basically that's the ratio of the words used to the length of the text. It's not really important in this iteration, but in versions 3 and 4, which I'm currently in the process of mapping out right now, they'll be far more important. There's also a fork of this code that I'm looking at implementing as well called Intercepticon. I'm not really going to get into detail about what it is, but lexical diversity will be far more important in it than it is in the current iteration. But basically, we move from there to tokenize the tweets, separate it into words. We could do it into sentences as well, but in this case, we're just doing it into words. We add it to the corpus, and for the corpus, I use the phrase BOW in the code for the variable, but just to create a bag of words. We get a little bit more statistics on the text of the tweets. So we look for things like frequency analysis, most common mentions, most common hashtags, any links that are shared as well. And then we also pick up the post interval, which that is why epoch time was important, because then we can determine about how far apart on average the account posts, so that whenever we set Decepticon and let it run and just walk away from it, we have it posting at something that appears to be us. From there, we move into the generate module. And at that point, we use the length of the text to establish our vector sizes and sequences. We look for the number of unique patterns in the corpus. Then we do a little bit of housekeeping, setting some files up associated with the model so that the tool can repetitively learn from it. If you look at some of Decepticon's tweets from my C_3PJo account from when it was first starting to tweet, as opposed to some of the ones that it's doing now on the DC865_owl account, which I'll show you, they are vastly different in terms of the quality. And a lot of that has to do with I've been letting it run repetitively as opposed to starting and stopping it and wiping out the model every single time. So it has the capability to actually learn things now. From there, we move into the trainer module. That's going to build us a pseudo-random seed, and then it's going to assess the predictions, create what is the actual tweet. We have a logic check to ensure that the tweet's short enough to be able to tweet it. And then we remove links, known characters to occur. So things that's not normal to written text. In the beginning, when I first started tweeting as Decepticon, I had a lot of problems with it doing several patterns of an apostrophe followed by a comma, as well as a few misplaced brackets. So once all those things are cleaned out, it tweets. So here's the time for the demonstration, and that's the one thing I did not open in advance, but we are in luck because I have it right here. I'm going to move it over to the appropriate screen. And that's not the right one. My apologies. So we're just going to have to go in a different order. It did not output as it was supposed to. Yay. So anyway, as we go with it, right here is the code. So we kick it off, Decepticon bot.py. It's going to run through. So this is just it doing Decepticon things, getting everything ready, getting the tensors going. Right now, it's not leveraging any GPU. So it's going through, it's connected to Twitter, it's pulling the tweets down. This may be the one that flubs up on me. So there's the frequency analysis of hashtags, all that fun stuff. So we'll go back here really quickly. So as you can see here, in terms of the analysis, in the account that it's analyzing, which I've altered the code for it to look at the C3PJo account, even though that's not what it's tweeting as, I've used hashtag OSINT, OSINT search party, Decepticon 23 times, OPSEC, OSINT for good. I did a Rickroll, and while I was training this, there's some stuff with the Raven, T.S. Eliot. I tweeted out All-Star from Smash Mouth, social engineering, some stuff there as well, OSINT the planet. and CTF. So that's the hashtags I was using. And then in terms of accounts that were mentioned, I've mentioned Tracelabs 4 times, Black Hat once, the DC865 Owl, Hackfest Canada, Dave Kennedy, RDS Web, Cass Stoner, Fatality, and National Child Protection Task Force. So now it's going to look through the characters and vocabulary. And then from here, I'm going to be speeding things up. So it's about to start running through the epochs. This is the time that it goes onto the GPU and executes the model. So just skipping ahead, this is just watching it go. Depending on how big your data set is, the way I've got the code structured now is it writes everything to a data frame. And then from there, it continues to store it and then repetitively goes back to it. This is just another video continuing the process, showing how it moves from one epoch to another. So we see that the loss is improved, which deals with the relationship between everything. What I didn't mention is as the long short-term memory model is executing, there's a function within the code that's going to convert all of the letters, all the words into numbers. And as that works, we convert to run the memory model, and then we convert to move it back. So this is just on another epoch. So just speeding all that along. Because sitting and watching this is kind of like watching paint dry. It's going to move from this epoch to another epoch. So just moving forward with that as well, just to make sure we have enough time here. So again, it's going to move through that, sits for a minute, and then go with the next one. So with this one, we'll just skip ahead. So it's going to move into the 5th epoch here. So there it moves. And every time we're improving the loss, which is good. With PyTorch, I was able to get a lower loss number, but at the same time, I wasn't able to get the good accuracy with it. So we have that. Now, this is after it's already created. So it had finished the 5th epoch, created the random seed, and then just processed it. And honestly, this is not the most ideal of a tweet, but in terms of abandoning an account, it's accurate enough. So let me go here. This right here is showing as the Decepticon bot stopped and tweeted, it goes into the sleeping period. And I altered the code to get the sleep period to be between 1 and 2 minutes for this, so that I could capture this without having to sit and watch it or record a couple hours of material and then edit that out. So as it works through here, we'll just go back just a smidge. So there it triggers the code again. It works again. Right here we see there's the posting interval in seconds. There's all the lexical diversity things I talked about as well. So then it just continues. We go through, runs through everything, goes through. Now it's starting its epochs. And we have that. And then right here is the, this is JTOP running on the Jetson that I'm using. So this is showing it just running through everything before we kick anything off. So we have, a little bit of a memory load. The CPUs are running, but they're not really taxed. The GPU is not doing anything. So as we see right here, apparently my neighbors decided to mow their lawn at 8:30 in the morning. If it wasn't for this conference, I definitely wouldn't have been awake this early. So it's just working through here. And about this time, as we see memory creep up, we're gonna observe the GPU kick on, and there it goes. So this is during an epoch. This is as the model is running on the GPU. So now we see the GPUs pegged out, CPUs getting more activity. And I gave this a lot of swap space, to be honest, because in the earlier models, it was leveraging memory very heavily, and it was causing me to causing the system to actually freeze up and just not be worthwhile. So I ended up, as you can see here, it's got like 48 gigs of swap space because the platform only has 4 gigs of RAM. So I've seen where the swap gets executed to about 2 gigs, depending on what's going on. In this version, not so much, but in the version that will be taking other people's tweets and using that likeness, that does take quite a bit of swap space. And that's the demo portion. If I wanted to be a really punny metalhead, I could probably say that's the demo Borgir. Notice I'm really passionate about OSINT and a very poor comedian. But anyway, about the project itself, it started around December 2019. And as with anything else, there's plenty of hurdles. I had shiny objects, squirrels, distractions, other things happened as well. And that obviously slowed things down. And in the past, I'd written a few things in Python, like WikiLeaker, for example, which is also a Recon NG module. It basically uses the requests library within Python to search WikiLeaks for existence of a domain. But I'm always trying to push myself further. I'm trying to find ways to marry other disciplines to be able to find ways to do things that are out of the box. Like, for example, last year I was presenting a talk called Social Forensication that basically operated under the pretense that as a social engineer, I would gain access to a facility, convince someone that I needed to take a memory image, take the memory image out, and then do offensive memory forensics to be able to pull passwords and other juicy tidbits of data from memory. In the case where the person didn't have domain administrator, that was okay because I had also written a script on a rubber ducky that dumped part of Windows to be able to take the Wi-Fi password. And then I also had a thing where it also did proc dump on Chrome or Firefox to take passwords that may potentially be stored in memory. So anyway, I've been reading about natural language processing and machine learning for some time and how to do things in Python. And the tutorials in the books, don't get me wrong, they're great, but you can only go through the quick fox jumps over the lazy rabbit so many times before you just lose interest. So this project was something that was supposed to help me flex those muscles and learn to fly, if you will. And then with that, I started doing a little bit more work with Operation Safe Escape, and it's like, hey, this would be a really good fit for this. And I've not trained them on the code yet. It's not in use for their clients yet, but that is something that is on the roadmap as well. So also about the project, in March, it stalled. And it didn't stall because I was on the road basically living in an airport. It stalled because everything in the world just changed. I mean, I think we can all agree that our world's changed drastically between February/March and now. But anyway, I was on Brian Brake's CSEC East meetup virtually, and one of the other presenters was talking about this Jetson platform. I was like, what's that? So I started to take a look at it, and I ended up porting the code over and resumed developing the tool that way. Because the VM I was using, I mean, it wasn't weak, but it didn't have like hardcore GPU. I had given the virtual machine 3 cores and 8 gigs of RAM running on my MacBook. So, I mean, it wasn't anything to scoff at, but it wasn't anything to be like super proud of either. And granted, a Jetson Nano platform is only about 100 to 150 American dollars, but it's a little bit nerdier too. So this is the Jetson Nano. The pictures we see on the right is the actual Nano developer kit, the single board. That's what I started with, and then I got to looking into it a little bit more, and I looked at adding the T300 expansion card. So as you can see, that it works via a USB 3.1 bridge. The T300 platform allows you to connect a solid-state hard drive to it. So my current system, I have both a 1 terabyte and a 64 gig solid-state drive. The actual operating system for this is running off a 256 gig micro SD card. So this is just a little bit bigger than a Raspberry Pi. I mean, it's honestly, the board is about twice as wide, but that's really about it. So it's not too terribly big. My current rig, everything involved, costs about 250 American dollars. Specifications on it, it's got a quad-core ARM processor with 4 gigs of RAM, and it's got the 128 CUDA core Maxwell GPU. This is what the case looks like. I have mine in that case with a fan on it. I don't have the Wi-Fi antennas or the camera built in. I could put them in. I just have no desire to right now. But we have the HDMI, the USB, micro USB, and Ethernet. So that's basically what I'm running with. Why did I use this platform? Well, it's external to my regular host, so it's not taking computing cycles away from other things like the book that I'm in the process of finishing. It's not taking away from my ability to give presentations. It's not eating up all my resources. I can still listen to my YouTube music as I'm working, and everything's fine. It has that enhanced GPU so that I can expedite the analysis. When I first got the Jetson platform, I was able to, it took me about 53 minutes for a single epoch on the virtual machine. I can tear through 5 epochs given the size of the data set right now. And depending on which data set, it varies between half an hour and about an hour and a half. So, and with each epoch, it becomes more and more accurate. So that's definitely an added bonus. And then, of course, there was the recommendation that I mentioned. So, lessons learned. Data science is not a walk in the park, especially if you don't have a heavy math background. My undergrad and master's are both in IT with focus in security. So, officially, the highest college math courses I have taken have been college algebra and statistics, not even calculus-based statistics, just statistics. So I had a pretty heavy learning curve with some of that stuff. I learned that PyTorch is faster, but it's less reliable as I've got it programmed right now. It's probably no fault of PyTorch. It's probably totally on Joe Gray, but I haven't got it completed yet. If you test it on your regular account, make sure that you have some stuff of substance. As some of you may know, I offer OSINT training as the OSINTian, and I tweet very frequently of my upcoming course offerings. Well, that came back and bit me because when Decepticon first started running, it was trying to promote training from the past and fictional upcoming training. So you want to make sure you have some things of substance that it can actually operate off of as well. That being said, if all you ever do is tweet promotional stuff, then let it do its thing because you want it to act as much like you as possible. But in this case, I wanted it to seem more like a person that's doing a lot more interaction on Twitter. Also, be prepared for people to get annoyed with you. I got quite a few messages from people acknowledging, hey, I understand you're doing research in disinformation and deception, but the stuff Decepticon's posting is spammy and obnoxious. And honestly, it probably wouldn't have been that big of a deal if I had have stuck to the regular tweet interval. But the thing about the regular tweet interval for me is it was about 12 days in between tweets, and that just doesn't make for any compelling presentations. I also learned that people get confused when you start tweeting things like the Raven. They get a little irritated when you start tweeting All-Star and a Rickroll. And honestly, throughout the whole process, there was a whole lot of hypotheses and a whole lot of A/B testing. There's a lot of, let's see how this works. Let's see what this changes and what we can derive from this. Given that this is dealing with data science, which is adjacent to like data mining, data lakes, data oceans, so forth and so on, an array of tweets, around 200 tweets at 280 characters, is a very small data set for an LSTM. So if after some time, after you have your repository built up, then it's going to be a lot more accurate. In terms of limitations, right now it's to make use of the CUDA cores and the GPU. If you do it on a VM or just hardware, it can be very time consuming. I've looked into leasing GPU processing in the cloud, and it seems to be very, very expensive. And then, at the same time, a lot of in the use case for like Operation Safe Escape, people may have completely deleted all tweets, or they may have just set the account up. You're going to need to get something posted for it to have anything to work off of. Alternatively, you may also have to pull from somebody else, as I'm doing with my current version of the code right now. So we'll take a quick look at the Twitter account that's posting from it right now. So this is just an account that I had an API key for. So as you can see, about 5 minutes into this presentation, it started tweeting part of the Rickroll. Before that, it was tweeting about the Raven. We wear the mask. So it's pulling stuff from a lot of those different things. So that's this account. Searching here, let me actually. Cool, thanks. What am I looking for here? Hashtag Decepticon. So looking for hashtag Decepticon. So this is just some of the stuff that I did. I'm gonna do some advanced searching on it and only look from my account. This makes it a little bit easier. So there's some Decepticon stuff. And it's not only, I need to add, that's what it is. That's what it's missing. My apologies. So now this is all looking at this. Previously I'd mentioned Workshop Con on layer 8 because I gave training there. This is just pulling through some stuff. As you can see, it's tagged Black Hat a few times. The tool's being presented at Arsenal on August 5th. But as it just goes through, it just goes through and pulls stuff out. Again, this is not necessarily the most accurate, but it's somewhat accurate enough. So this stuff right here, this is actually pulling from somebody else's tweet. But if we scroll down, notice this right here. This is what I was talking about with the commas and the apostrophes. We see that here as well. And it just got kind of really obnoxious really quickly. But then we'll also take a look at the actual code itself, time permitting. So basically, we'll start here at the absolute bottom as everything's set up. So here, this is set up for future versions to be able to input users. The stop words are not used in this iteration, but I may add them back in another one. That's just removing words like and the and stuff like that. The physical device sets up the GPU for everything. This is connecting to Twitter. So there's an adjacent Python file that you have to input your Twitter API credentials into. I call it t_keys.py. And that's going to reference everything here. And then from there, we have tweet mode extended. That's going to get the full tweet as opposed to a preview. Sleep on rate limit true. The sequential model is putting in the LSTM. And then here, because this is the one that's actively running as DC865OWL right now, I've changed it from get timeline to get user timeline so that it can pull C3P Joes. I'm not looking at replies right now. That'll be in future iterations. So once it goes into login, actually first we do all the imports. That's in this file right here. Quite a bit of stuff to import. I'm probably going to clean that up a little bit and release that soon. Adrian Sanabria, Goldar, Nedyak, Bill, that guy, Nasirasek, and JFerg helped out with some of the coding. James, November, Cheerio, Wondersmith Ray, and Adrian is, again allowed me to pull tweets from their accounts. But anyway, we log in, we check to verify there's a directory. The CSV file is what we're looking for. If the CSV file exists, we're going to import it because that's what's going to contain the previous tweets. If it doesn't exist, then we just we create it and then go from there. Here we have the lexical diversity, but we're moving from there to tokenization. So here we see that I've created empty lists globally. For the tweet, we pull down the full text, split it. This right here, the regular expressions, that's just going to be able to pull to populate the bag of hashtags, mentions, and links. And then we move to the hopper. The hopper, we've got the full text again. We've got the tweet created at time. And then from there, we have the time of, this is where we're converting it over to epoch time. So tweet created at, then it goes to make time in this format. And then it moves from that format to epoch time. We execute lexical diversity, and then we replace, we just cut out all mentions and hashtags. Honestly, if you wanted to seem even more natural, you could cut those two things out if you wanted to. And then from there, we append the whatever's there with the tweets, the times, and the lexical diversity. And then we drop duplicates just so that we don't have undue influence here. Then we move into the sorter. This is just where we're going to build our bag of words and do the tokenization. So from there, we're going to collect some stats, do some frequency analysis. So the stats, this is lexical diversity. Then we're going to look at the mean standard deviation of lexical diversities. So and then we define the post interval here. Frequency analysis, this is just showing us the word counts for the bags of hashtags, links, and mentions. Then as we get into the generate function, this is where we convert the characters to numbers. The input length is the length of the bag of words, so that's your vector size. Spit all that out. We give it a sequence length of 500. Build everything, set our patterns up, set it up to shape as correct. Here, run through pre-modeling, which is right here, which we create a JSON file so that we can store the model in that as well. We also, for redundancy's sake, save the model as an H5 file. Here we have everything configured in loaded model compile for categorical cross entropy using the RMS prop optimizer. Beyond that, I've established 5 epochs and a batch size of 32. And then everything just works through on that. And with the pre-modeling, we have if this file exists, this is loading the old model. If not, then it just moves into modeling. So it builds the 224-bit LSTM, and then we have the epochs, the batch size. Right now I'm running on 1 epoch for the first run, and every other one's 5. But nevertheless, and then through the trainer, this is building the pattern. So it's just taking the data that comes from the modeling and what have you. Then we have the tweet creator. So this is just pulling everything, converting it back, building everything into the pattern. And then I've determined that we can have about 40 words and 280 characters fit in. I have all this stuff to remove out any links, erroneous characters, any of that fun stuff. There's definitely a more efficient way to do it. I just haven't done it yet. I'm sure I could just write a script and have it import it and run it that way. But then here we see that it posts the update and that it's appending hashtag Decepticon and mentioning Hack in the Box Security Conference. And then it moves into the repeater. The repeater right here is the normal sleeping interval. You can set that random. I've got it to subtract a random interval from it so it's not too detectable, but you could do whatever you want with that. It sleeps and then it kicks off subsequent, which basically just triggers the process all over again. So that being said, looks like I'm bumping right up against the time. I'll open it up for any questions simultaneously during this portion. If you want to contact me, here's my contact information. Again, there's the GitHub repo. If you're interested in playing with the Jetson Nano platform, there is an Amazon idea list with pretty much everything you're going to need to get started. Also, at the end of the week, I'm offering open source intelligence training. If anyone's interested in attending the training, use coupon code HITB 1337 for 25% off. So I'm doing a 6-hour training on, it will be August 2nd. I put that incorrectly on the bottom thing, but August 2nd from 8 a.m. to 2 p.m. Singapore time. And then I'm doing 2 3-hour sessions the days before that from 6 to 9 a.m. Singapore time. So again, if there are any questions, please feel free to reach out. But if there are none, thank you very much. I appreciate your time. Be safe. Thank you for taking time out of your day to spend with me sharing my passion. Thanks.
Thank you, Joe. And as it happens, we have a bunch of questions. But as you also mentioned, we are kind of pressing for time. So trying to keep your answer brief. Have you considered using GPT-2 or GPT-3 for text generation?
I never came across those. GPT-2 and 3, I'm writing those down to take a look at it. I wasn't aware of that.
Okay, cool. Another one is, how big is the LSTM? How much memory does it consume and how much attention can you give it?
Well, on the Jetson platform, I've been able to run it at 224 bits with 32-bit batch sizes without running out of memory. Because if I tried 256-bit or 512 or 1024, my apologies, I got out of memory errors, even with the swap space. So the LSTM size is going to depend upon the hardware that you have it on. If you're using the Jetson platform and you have it on like an Xavier, then you're going to be able to have more space for it. If you are doing it on like a gaming PC with like a GeForce 2070, then you're going to have a lot more flexibility with it.
Okay, then the next question is, what is the size of the corpus?
The size of the corpus is directly relative to the number of tweets that is ingested into the data frame and the length of the tweets.
And final question, will you be posting a full article or white paper on setting everything up, including building for the Jetson?
You know, I hadn't thought about that, but it is on my to-do list now.
Okay, awesome.
And I will be posting it on Medium and sharing it on Twitter.
Okay, well, brilliant. That is all the questions we have, which is kind of good because we're pretty much out of time as well. Thank you, Joe, for that amazing talk. The next talk that we will be having here is Serverless Security Attack and Defense by Pawel Rzepa, and that will be up in about 5 minutes. Don't go anywhere. Right, and we are back. And as I said just a moment ago, our next speaker is Pawel Rzepa, who is going to talk about serverless security, attack and defense. Pawel, take it away.
Thank you very much, Cooper. And welcome everybody on my session, and thank you for finding time for that. My name is Pawel Rzepa, and today I'd like to present you some attack vectors and mitigations.
Is there a problem, Pawel?
I can hear my voice. So, anyway, okay, just not to waste your time. So today I'd like to present you some attack vectors and mitigations. Yes, I can see the echo of me.
I may have been sending you that. It's been turned off.
Oh, perfect. Thank you very much. So, what can you expect during this presentation? Firstly, I will show you some differences in running function as a. Firstly, I will show you some differences.
Pawel, I think you may have the live stream YouTube in the background running.
Function as a service using services from various providers like AWS, Azure, and GCP. Then I will present my little research regarding dependency poisoning. Furthermore, we'll go through an attack called denial of wallet, which is specific to all cloud applications. Then I will show you the problem of secrets leaks from serverless applications. And next, we'll go through the real plague of serverless that are over-permissive roles. And lastly, we'll go through the problem of dangling resources, which actually motivates me to make this presentation. Before that, let me introduce myself. My name is Pawel Rzepa, and I work as a senior security consultant in Securing in Poland. And on a daily basis, I perform cloud security assessments as well as application penetration testing. You can find some of my articles on my Medium blog, and from time to time, I share the latest news from cloud security world. So if you're interested, I encourage you to follow me on my LinkedIn and Twitter accounts. For all those of you who are not familiar with the concept of serverless, let me quickly explain it to you on a very simple example. Imagine that you run your own blog for some time using just a static content like HTML, CSS, and JavaScript. Then you decide to put there a buy button to sell your course. That means that you now have to confirm that the customer paid for your course by implementing a webhook and handling the confirmation from the payment provider. Then you have to send an email to your customer with the access token to your course, right? And finally, you probably would like to get a daily report regarding how many courses you've already sold. If you're using only static content, so far that brings some challenges. You have to refactor your website to manage dynamic content and refactor your code. What is more, you don't know how big traffic you will have, and you have to pay for hosting based only on your assumptions of the traffic. And finally, you have to maintain your server by yourself. That means that any patch management on the operating system or any latency issues are on your side. In the opposite, if you choose the serverless architecture, it fits well to such case, because the only thing you have to do is adding just free function as a service where you are completely focused only on functionalities without any maintain stuff. So the serverless means that you don't have to worry about what server your function as a service is running on, because that is handled by a provider, so in this case, Amazon. The code execution is triggered by an event, and there are various event sources. For example, it can be uploading a file to your S3 bucket or an HTTP GET request to your API gateway. The event triggers the runtime environment and executes the Lambda function code. Lambda functions work as a lightweight micro virtual machine based on Amazon Linux image. If you're interested to find out how does the Lambda environment works, you can just visit lambdashell.com, and the project gives you a shell to Lambda environment without a need to have the AWS account. So, for example, here you can see that the code is stored in the var task directory. But what is so there is the full source code of your Lambda function. But what is more interesting from the security point of view are the environment variables, because there are all the secrets in the plaintext, as well as the AWS access keys to the execution role that is attached to this particular Lambda function. So every instance of the Lambda function requires a role with assigned permissions, which is called the execution role. For example, every Lambda function needs privileges to put logs to CloudWatch service, or your Lambda has to be authorized to put or read an entry in DynamoDB. And this is done by assigned execution roles. One more important thing is that each Lambda function is sandboxed, so it is separated from other functions. In Azure, functions are deployed as app service. So for example, to deploy them, you have to also deploy the storage account where your functions are stored. What is more interesting is the fact that all the functions are deployed in the same app service. So they are sharing the whole runtime environment. So you can see on the slide here that there are 3 Azure functions, and only 2 of them are HTTP triggered, and 1 is triggered by a timer. So for example, like running the Azure function once a day. Now, let me show you an example. So here in my app service called Azure Shell Demo, I deployed the demo shell function, and using the CMD parameter, I can perform any command on this environment. So surprisingly, Azure functions are running on Windows. However, on Linux, it is also possible, but it is not so common. In the directory that is home site www.root, you can see that there are all 3 functions. So let's go to one of it. So here you can see that there's the function JSON file where there is all the configuration regarding this particular function, like for example, if you can anonymously access this or not, or you require a token. In the run CSX file, you can see the source code of this demo shell function. And again, let's print out all the environment variables. In the Windows environment, we are doing it using command set. And again, you can see that all the environment variables, including secrets, are in plain text. any login pass to a third party, or for example, the connection string to your storage account, which is very important, which will be very important in the next slide. So please remember it. So what about the GCP? Here I'm running the netcat listener on the lead port, and then I'm running the GCP cloud function to get a shell. And surprisingly, all the GCP functions are run on the root account. You can also print out the environment variables, which can store the environment variables, but there are no access keys like in Lambda shell. To access the keys, or rather the token, which is assigned as an execution role to this particular cloud function, you have to use the metadata service, which is accessible under the address 169.254, 169.254. And this is the link local address, what means it can be accessed only by the cloud function. And the difference with to the Lambda shell is that you have to AWS at all, you have to put a header called metadata flavor. So if your cloud function has the server-side request for the vulnerability, it is hard to just get the token, but because you have to add this header called metadata flavor. So let's see, you can print out the scope of the permissions of the service account that is attached to this cloud function. And you can see that by default, all the cloud functions are having the editor role, which means almost like administrator. The only difference between the owner is the fact that the owner can also manage the billing service. And what is very interesting, you have the, by default, you have the permissions, the editor role to cloud platform, what means you can do basically anything. Like read, write, anything. So to access a token, so simply access the metadata service and the endpoint token. And with this token, you can now authorize yourself using the, for example, the gcloud CLI and do arbitrary action. Okay. All right. The main character of the story I'm going to present is Bob. And Bob is a junior developer who has recently started programming serverless applications built with Lambda functions. His applications are developed in the test environment and they will be used only internally. So absolutely nobody cares about any security testing or any special isolation of this code. Which is pretty common approach, unfortunately, because in the monolithic architecture, everybody thinks that you cannot access those internal applications from the public internet. However, in serverless, the situation looks a little bit different, what will be presented in the next slides. Furthermore, Bob uses serverless framework, which is the most common way to deploy the applications in AWS. The serverless framework based on serverless configuration file generates the CloudFormation templates and also zip your Lambda functions with all the dependencies. All those steps, of course, can be done manually, but the serverless framework automates most of such steps and makes developers' life much easier. So let's go through the first attack that is called dependency poisoning. Let's take a look on Bob's first challenge. Files uploaded to the particular S3 bucket should be automatically renamed with some prefix. So the idea here is simple. Once the file named test_new_png, for example, is uploaded to S3 bucket, the event triggers the Lambda function, and the event is basically a JSON file where you can find such information as name of the bucket to which the file is uploaded, or the name of uploaded file, and then the Lambda code should rename the uploaded file and remove the old one from the bucket. Hope it is clear and easy for everyone. Like many other developers, instead of writing the code from the scratch, Bob started searching for the ready-to-use code. So he searched the internet through the places like Stack Overflow or npm.js repositories. And luckily, in npm.js repository, he found a package called S3 rename. And analyzing its usage in a README file, Bob found that it is exactly what he's looking for. That is, it renames the S3 object. So Bob writes the following code. As you can see, he extracts from the event.json file the name of the bucket and the name of the uploaded file here in this line, and then he takes the name of the old file and put the scanme prefix. And all of that is done by the S3 rename method from the S3 rename package. After uploading the file test_new_png, Bob sees that the scanme prefix is added. Moreover, in the CloudWatch logs, everything seems to perfectly work. So Bob is super happy how easily and quickly he was able to finish this task. But when we analyze the S3 rename package source code, we will see that there's a line with obfuscated JavaScript code. This line of the code basically does the following: verify if there is the AWS access key ID environment variable, and if so, send it to the attacker's server. So the developer is totally not aware that his Lambda function is sent the sensitive data like the AWS access key ID. To be honest, I've created the S3 rename package and published it just for the demo of this presentation. However, there was more than 500 downloads of this package, and on my server, I've received not only Bob's AWS access key, what means somebody else was also using this package like Bob, what is pretty scary. Of course, the S3 rename package is no longer available in npm.js repository. However, unfortunately, there are no mechanisms preventing you from putting the malicious code. And such attack would also work in GCP and Azure. Can we do anything to defend against such attacks? First of all, by default, Lambda function is executed outside of your VPC. However, you can run VPC-enabled Lambda function in private subnet. And then, using security groups, you can control any outbound traffic. If you need access to any of your AWS resources, like for example DynamoDB, you can use the VPC endpoints to communicate with them, and any traffic is not going out of the AWS infrastructure. And similar defense approach can be done in GCP and Azure. Now, do such attacks happen in real life? Let me tell you the story about the dependency poisoning in a very common NPM package called event stream. Event stream is kind of a toolkit to handle streams in your application. It is a very popular package with almost 2 million downloads weekly, at least at the moment of doing this screenshot. And it is broadly used among many various applications. The package was developed and maintained by Dominic Tarr. Dominic is an experienced developer who's released many open source packages, 3.2 thousand followers, as well as the amount of his contributions to open source projects seems to be reasonable argument to trust this guy. However, at the end of 2018, it was found that one of the event stream contributor with a nickname Write9Control added malicious code to the event stream. Dominic Tarr replied. He emailed me and said he wanted to maintain the module, so I gave it to him. I don't get anything from maintaining this module, and I don't even use it anymore, and haven't for years. So let me repeat the scariest thing here. He emailed me. So as you can see, gaining permissions to push arbitrary malicious code to the dependency used by thousands of other applications is as easy as sending an email with the direct request. So what did Write9Control do? He added the malicious code as the dependency of the event stream package, which was called the flatmap stream. Then, only when copy dash package was found in other dependencies of the application, the malicious code was decrypted and executed. The copy dash is a popular Bitcoin platform. So, as you may already guessed, the goal of the malicious code was to steal Bitcoin wallets. The whole attack was uncovered for 48 days, and the only reason why it was detected was sheer luck. Because one of the methods used by flatmap stream became deprecated. So all the applications that used the event stream with the malicious flatmap stream dependency were notified about the deprecated method, and this was the method related with crypto. So people were pretty scared that they are not using any crypto. So why those warnings are coming to them? There's a really nice write-up regarding this story. So if you'd like to read it in details, check it out under this link. Please be aware that such attacks can happen in any dependency of the dependency. So for example, you can see the event stream in latest version has just 7 dependencies. However, there are other packages, like for example, Express package. Which has much more dependencies. So if you're using Express framework in your application, then a malicious code can be injected through any of those dots. Pretty scary, huh? Regarding defense, there are available various tools which tracks any known vulnerabilities in dependencies, and the most popular are Snyk and Black Duck, and the open source OWASP dependency track. You can also run npm audits to detect any known vulnerabilities before releasing the application. And there are also for Python projects, similar thing can be done using the PyApp, and for .NET projects, you can use a tool like .NET Retire, and you can find them in GitHub. So let's go to another attack, denial of wallet. The second Bob's second challenge is to add functionality that only some extensions should be scanned. So Bob again searched through the internet in search of the proper regular expression, and he combined few of them. And after several tests, it seems that everything works good. So let's analyze this regular expression. As you can see, the word test correctly doesn't match. The word test PDF also doesn't work, which is also correct. However, if we call the file like with numerous A letters, we can see that we face the catastrophic backtracking. And let's take a look on it. In this particular regular expression, the regex engine can make various decisions. So if there's no match after analyzing whole string, the regex engine goes back to the previous point where other decision could be made and keep searching. If there's again no match, then the regex engine again goes back and makes different decision. In consequence, there are so many checks that it consumes all available memory. And most of regex engines support backtracking. However, not all of them. For example, in Go language, the REDOS attacks wouldn't work. So if you're using the serverless framework, then the default timeout for your Lambda is 6 seconds, what can be extended to 15 minutes. In Azure and GCP, the default timeouts are 5 minutes, which can be extended to 10 minutes. What you should know about pricing is that you are billed not only for the amount of requests, but also for the computing time. And it also depends on the allocated amount of memory. So sending 100,000 requests may do a significant financial loss, like 100,000 requests, each billed for 15 minutes, then it will cost around $1,500 of US dollars. And regarding pricing, there are no big differences in Azure and GCP. There are, like GCP is almost twice more. However, you have for free, instead of 1 million requests, you can send 2 million requests. So in general, we can say that there are no big differences between the providers. If you're unsure regarding your regular expression, it's always a good thing to check them against REDOS attacks. And there are many available online tools like REDOS checker search.sh. And by just pasting the regex, you can test it if there are possible REDOS attacks. So what you can do to protect against such attacks? You can adjust Lambda concurrent execution limits, so not to allow to run too many Lambda parallelly. And also you can put the throttling limits in API gateway. Furthermore, you should track anomalies in logs, and you can also set up a billing alarm. So if there are any anomalies, you should be quickly notified that something is not okay and it requires your attention. Now, let's go through the secrets leak. The Bob's third challenge is the Lambda function should create a new entry in DynamoDB. A very common practice that I can observe in my commercial cloud security assessments is that a lot of developers store secrets in plaintext. But you should be aware that the plaintext secrets aren't stored only in the Lambda function configuration. If you are using the serverless framework, the configuration with plaintext secrets is stored in S3 bucket, which can be accessed by anyone in your AWS account who has the read S3 permissions. So when you analyze the automatically generated bucket policy, you can see that there is no restrictions who can read the objects in this bucket. So if an attacker compromises one of your AWS user with limited permissions to just S3 read action, which is pretty common, it is possible to read all those secrets and then perform further attacks. To prevent such leaks, remember always to store your secrets encrypted. And if you use AWS Secret Manager, then you can refer to those secret values using the following syntax. And very similar approach is in Azure, but the secret manager is called the Key Vault, and in GCP, it is also called a secret manager like in AWS. One thing to point out here is the official Azure documentation, where you can find such information that secrets are always encrypted when stored by default. But this is partially true, and some developers may mistakenly think that they do not need to encrypt those values. Because every user in your Azure tenant who has the access to app service can simply just display them in plain text. Furthermore, what is less obvious is the kudu service, and the kudu service is running on the top of app service, and it is used, for example, for debugging tasks like dumping memory. And if you access this kudu, if you have the access to kudu, then you can print out all the environment variables. And among those environment variables, you can find also the connection string to your storage account. And using storage account, you can upload an arbitrary function which displays all environment variables. Let me show you an example. So here, I'm trying to run the function which is called pwned, and obviously it will not work. I have the 404 error because there is no such function. However, if I compromise the storage account inside www.root, I can see all those three functions. But what I can do is just upload an arbitrary new function. So I call it pwned. And as you can see, there is the function JSON with the configuration of this function to be accessible anonymously. And there's the code to simply print out the environment variables to know all those secrets. And now you can see that all of them are accessible just having the access to storage account. And based on the documentation, so somebody may think that it shouldn't be a problem because in the storage account, the values are always encrypted. The secrets are always encrypted. And now time for the really plug of the serverless applications, that is the over-permissive roles. So Bob has the fourth challenge: create the proof of concept application where internal candidates from his organization can submit their CVs. So here is the little demo. The static content is in Polish, but it is not important. You can see that there is the link to CV in doc file, which I'm sending to the server. And after sending my CV, I can see the confirmation that thank you, we just received your CV. But if we just do a very simple fuzzing, like adding the semicolon, we can see that actually we have the remote code execution here because there is used the cat doc program to process this file. So if I add the env comment, all the environment variables will be printed out. There are some errors, but it is not important because in the bottom of the output, you can see that I have the access to the session token, to the access key, and the secret access key. So all the information needed to use the function role that is execution role that is attached to this particular function. So just to visualize you what happened, an attacker was able by sending the crafted HTTP request to the API gateway. It triggered Lambda, and using the remote code execution, it was possible to get keys to the execution role that is assigned to this Lambda. So a user can do anything in what is allowed by this particular role. But the problem is that those roles are very, very often over permissive. And it happened sometimes when I was looking why it happened, what is the reason. So one of the argument is, for example, if you are using the serverless framework, and just a reminder, it is the most common way of deploying the Lambda functions in AWS. There is by default you are sharing the IAM role across all the Lambda functions. So assume that only one Lambda function requires permissions to DynamoDB and S3 actions, and two others, and in one other Lambda function, there is the remote code execution vulnerability. And although this vulnerable Lambda function doesn't require the permissions to DynamoDB and the S3, it still have, because you deployed one role via the serverless framework for all those three functions. So what you can do is to use the plugin, which you have to explicitly install. And this plugin is called Serverless IAM Roles per function. And thanks to this plugin, you can create a role per each function. So in this particular case, you can create a role just for one function, and the attacker with vulnerable Lambda couldn't do much, at least nothing with the permissions with this role. But what if you can access resources only from AWS Lambda? In other words, if you are trying to use the access keys that you've just extracted, then sorry, but it is not allowed. So let me show you what attacker can do in this particular case. If the attacker has the remote code execution, it's still game over for you. So here, remember about the URL encoding. This is why those why you can see it here. And I'm just printing out the listing of the var tasks. So as you remember, there is the source code of the Lambda function. And if you using the command cat, you can print out the source code of this Lambda function, and you can see there that there are some actions regarding DynamoDB. So it is pretty obvious that this role needs some permissions with DynamoDB. So remember that it is the runtime execution environment for Node. So you can simply put a Node code to do anything from the Lambda inside of your Lambda function, inside of your AWS environment. So here I need to encode this. It is not required to encode all the characters, just the key of them, but yeah. So by putting it, I was able to print out all the content of this DynamoDB. And by the way, this demo comes from the serverless goat, which is a vulnerable serverless Lambda function accessible from the internet. There's no need to set up your own AWS account. So yeah, you can find it on the serverless -hackme. So yeah, have fun. This is not only the vulnerability of it. So what you can do to protect? Well, the most important thing is to follow least privilege principle. Use per function IAM role, so always limit every function to only actions that are really required. You should also harden your API gateway. There's something called the API gateway request validation. So, for example, if you are expecting only the string value, you can set up such validator, and any tries of remote code execution with the node source code, it wouldn't work. And the interesting things are in GCP that, as you remember from the beginning, by default, all cloud functions are run under the same service account with editor role that allows you to access everything. So you have to explicitly create unique service account per each function to limit their permissions. And in Azure, you should apply the role-based access control to limit the permissions. They are less granular than in AWS. However, you can also use the shared access signature tokens to get limited access to other resources. And this is the theory, because in reality, there are still developers who will just sit an additional work in all those steps. And they still believe it is just for internal usage. So there's no point in securing absolutely every function as a service. And this brings us to the last problem I want to touch, and this is the dangling resources. So, as you may remember from the beginning of the internet, a lot of server rooms looked like this. So totally mess, but all in all, it worked. And when we migrated to cloud, I think that the situation is pretty similar, because when I'm doing the cloud security assessments, there are a lot of unused resources. They're the resources which were used for years, but they are still accessible from the internet. And remember that finding dangling HTTP triggered function as a service is as simple as enumerating subdomains. In AWS infrastructure, you should look for the execute API endpoints. And in Azure Functions, this is also quite funny, because by default, all those functions, HTTP trigger functions, they are also accessible using the HTTP. So you have to explicitly turn off the HTTP without encryption. And in GCP, you can also find some available endpoints to access the cloud function. In Azure, you can see that there are two ways, at least two ways of accessing your function. And one way is to use the API key in the header which is called the xfunctions key, but you can also put the same API key as the get parameter. So if you searched through the Wayback Machine that is accessible under the URL webarchive.org cdx search, you can simply find a lot of Azure functions with the code parameter. So here, for example, you can see the PRD letters may point that it is the production function with the get token, and the get token is reflected, and all of it is accessible for everyone who's searching the Wayback Machine. And of course, the Wayback Machine is not the only source of such juicy information. So remember to regularly audit your cloud infrastructure and remove all not used resources, because any of them they are potential entry points for attacker to your infrastructure. So to sum up, let's go through all those what I said in this presentation. So firstly, we went through the dependency poisoning attacks. Then we went through the denial of wallet by RDoS attacks that are still a threat in serverless world. Furthermore, there are leaks that can be, for example, by printing out the environment variables, but more common would be to find those secrets in the buckets. And people are often not aware that those secrets are stored in the plain text, and everyone in their organization with the S3 read has access to this. And finally, we went through the over permissive roles that allows you to often hacking just one function is enough to compromise your whole infrastructure because of privilege escalations and things like that. Because gaining an access to the cloud is just a beginning. And if you are curious what can happen later with the access, what attacker can do, and you want to see the full cyber kill chain in AWS, please visit this link. There is my presentation from previous year. So I hope you will like it. Okay, so we're going to the end, and if you are interested in taking such cloud security assessment, or you have any questions regarding this, I'm doing it on a daily basis. So please just ping me, and I will be very, very happy if you can share feedback regarding this presentation. Do you like it? Do you think it is missing something I should add or modify? I will really appreciate. So thank you very, very much for your time, and wish you all the best.
Thank you, Pawel. I'm looking at Slido, and sadly there aren't any questions on there. So let's see. There is one question in a side channel that I got, and they're asking, since a lot of the things you discussed here are are Azure specific, is AWS, in your view, better?
Could you please repeat?
Since quite a few of the subjects examples you mentioned were Azure specific, do you consider AWS better?
No, I don't want to say that any provider is better. There are big differences. There are differences between them. However, all the attack vectors that I presented, they can be mitigated in every provider. The problem is that it always requires your additional steps, and this, I think, is the main blocker why many developers are not doing it. I think that it would be better on a very specific case to choose what is better, because which provider is better for this particular case, because there are some different limitations regarding the concurrency of function as a service or giving the granular permissions. But generally, I think that it would be, I cannot say that any provider is better, and I don't want to do it.
Okay, fair enough. That is the only questions we had. So oh, wait, no, something popped up again. Will you release a guideline for securing installations?
Securing installations like deployment of serverless applications?
Like a best practices document or a Medium post or a white paper?
Yes, there is already accessible on Medium one general, which is more focused on AWS. I didn't think about making it enhancing it for GCP and Azure, but well, yeah, it is, yeah, that's a good idea. So it will be on my to-do list. If you are interested, I'm planning in August to share the article regarding something different, but also very, very interesting, that are the HTTP request smuggling attacks in cloud, because surprisingly they work by default when you are using the cloud load balancers, for example. But it will be, yeah, with details, it will be on my Medium. So if you're interested, just please look on it at the end of August.
Okay, and I trust that when it's there, you will put a tweet out or something so people know, we have to look.
For sure.
Okay, awesome. Okay, I guess that's all then. Thank you very much, Pawel. We will be back in just under 10 minutes with Denis Legezo and his talk from authors of COMPFun, HTTP statuses as C2 commands and compromised TLS. We will be right Right, and it's the last talk of today. We have Denis Legezo with his talk from authors of COMPFun, HTTP statuses as C2 commands and compromised TLS. As before, this is a live talk, so if you have any questions, by all means drop into our Discord or throw them on Slido and I will ask them on your behalf. As mentioned, Denis Legezo, take it away.
So thanks Cooper, and thanks for everyone for coming. And let us spend the next hour with the following topic. In Kaspersky, I'm with the team who is in charge of the researching some targeted malware, doing rebooting, threat intelligence, etc., etc. So I would take one research, but I hope we would cover not only the research itself, but also some approaches, some interesting technical aspects of this research. And the plan looks like this. I don't want to make like a torture with PowerPoint. I hope we would just cover the most interesting parts. Also, the first part would be it's like two parts of this research. First one is related to the on-the-fly file infections. True, it was really the file infection, so it's really added something to the executable files, not so common nowadays. And the TLS encrypted traffic reading. Second one, the more modern part of this research, it's this application and the HTTP statuses as a control server, control commands, server commands. Please mind that Visa here is not standing for the payment system. Visa here, it stands for the Visa, well, like when I want to enter some country. So I hope my English here is right, and I name it right. It's like a permit for me to enter some country to get Visa before it. And after some also will describe two approaches, and the approach we promote during this research. And I hope we would have some around 15 minutes for the questions. Please don't hesitate to ask it in Discord. Let us go. And in such amount of time, I wouldn't cover all the technical details. For ones who are interested in more deep technical details of this research, of this malware, you could find the corresponding materials on SecureList.com. And here I would only emphasize the main parts for me. So how it's all started. If you are into the threat intel, maybe you are remembering the very first appearance of the COMPFun malware back in 2014. The company G-Data, I believe it's a German one, it's covering with malware so long time ago. But for sure, I'm not presenting this year some story from the so old days. In 2019, we found new malicious samples, which we are completely sure share the same code base with old COMPFun. So, and Mr. Cooper, if you don't mind, could you please mute your mic? I could hear you. So thanks a lot. And we found the new ones so it's quite obvious, code base is the same. And here on this slide, some the corresponding parts over this different malware. The idea is, so many years passed by, and they already have some proven and well-written malware. Why to make the new one? Why to develop the next version of it with all these new approaches? And the answer is it's related to the encrypted traffic, the TLS. And they was interested in this encrypted traffic from the targets and how they could get it. K-logging, yes, for example, K-logging is good. It's even before any encryption, they could get it. But maybe with nowadays, so security system, it's a little bit too loud. Any security solution could catch this K-logging capabilities. Sorry, Mr. Cooper, I think it's your mic is on, if you can hear me. could you please mute your mic, your mic, because I think all the participants also could hear the sound. If you are with us, please mute. Okay, we'll continue. So, what else? Decrypting the encrypted traffic? I don't think so. With the current current level of the TLS, not in reasonable time. Not. But what else? Certificate pre-install. The cert pre-install, yes, maybe it's a good idea to compromise to facilitate some MITM abilities and not as loud as the keylogging. But imagine the target is inside some huge corporate infrastructure, and the authors, the operators don't want to listen all the hosts. They want to mark the precise host of interest and not decrypt all the traffic. Okay, so the next idea for them is to mark the packets of interest. But if someone try to make it with some driver and this proxy driver to manipulate this network traffic, it's once again maybe too loud. But in this malware, why we love it and research it, the one technical decision was made how to mark this session, TLS session, without even touch the network packets at all, without any manipulation with the network traffic. So how it's possible? The answer is the client hello field. So for sure you're familiar with on the very early stage of the TLS communication between client and server, you have the client hello field. And let me remind you, this field is completely not related to the encryption itself. So if you spoof this field, you wouldn't weak the encryption. It's just the early stage. Okay, Mr. Server, let us use this version of TLS protocol, etc., etc. So effectively, it's just a random byte to facilitate the starting of the communication between the client and the server. And how they feel. So it's a random field, and for some bytes to be into it, step the random number generator is in use. And this is how the authors of this malware, we call it reductor, this reductor malware, how they mark the TLS section. So imagine, and let me try once again, Mr. Cooper, if you are with us, could you please mute your mic? Because we could hear you as well. So thanks if you are here. And in reality, not so many libraries are in charge of generating these pseudo-random numbers. This, in case of the browsers, for example, Firefox, Mozilla's browser, use NSS, in this case, NSS 3 DLL. Chrome browser use their own DLL, dynamic linked libraries, or quite huge one. And the native Windows application using Windows API, it's just quite obsolete function from Advanced API 32, like a crypt gen random. If you consult the MSDN, you would see Microsoft for several last years recommend not use it anymore, guys, quite obsolete. So please move to the bcrypt.dll. So the functions like a bcrypt gen random from the bcrypt is also the option for the native application. Not so many libraries. So we got two browsers, native applications, 4 libraries. What they've done, they just patch the generator of the pseudo-random numbers in memory, in process memory. In case of Firefox, in the Firefox address space. In case of Chrome browser, in the Chrome browser address space, whatever. So the function of the client hello generation field now is spoofed. So they don't, as I mentioned on the slides before, don't touch network traffic at all, just manipulate the generator. I like this idea. It's so for me, it's quite unusual and quite interesting. That's why I decided to research and cover it. And for sure, to patch, so thanks God, Firefox in source code, so they don't have to reverse the binary code. And in case of Chrome, for sure, they have to analyze this huge DLL which also includes the SSL capabilities. So to spoof with random number generator, pseudo random number generator. When I take a look at the size of the Chrome library, I decide to analyze Firefox source code, and so with a function like get new random or to this random number generator, it's end up in the SSL3 part of the code, and it's in charge of the creating of this client hello field. So perfect decision to mark the session. First of all, it's in the very beginning of the TLS session. On the second, it's you don't type the traffic, just fetch something in the process memory. Okay, so what is this unique IDs it looks like? Let's go further. What they put there? And if you remember the slide with all this list of the steps, they could use keylogging, blah, 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 with on some point, the idea of the installation of the certificate authority appears. So yeah, malware holds the certificate in the some host body. They first install it in system, and just to change the, organize the local meeting, if I could say. And the structure itself to mark the traffic, it looks like this. So instead of client hello, please mind it's still random. It's still random. If you saw with, if for example, some IDS, whatever, some security system would try to analyze to the randomness of the client hello, it wouldn't raise any flags, any red flags, because what they do, they just choose some XOR key, first for bytes, after it some const to check if it's field or this client hello field by the malware, or they don't interested in it, and two unique hashes. One hash, it's hardware-based hash. It's in many malware implemented like this. To get the unique target ID, you count the SMBIOS number, some processor features, etc., and counter any hash out of it, and you get the unique ID of the target hardware-based. And also certificate-based, all this, some count, some hash of the certificates, and put it also in this field. So quite a solution. XOR key, some predefined const, like an egg, like a check field, and two encrypted unique IDs. Also, I really like the Easter eggs inside the malware. In this case, in one place, they run a process remotely, and the credentials to run it was if you take the domain name, username, user password, you will get with UAC is useless. Okay, in their case, maybe UAC is also useless anyway. It's quite an old mechanism. Now we have a better ones, right? So UAC is useless is the one egg, and you see the one of C2 domains was a COMPFun.net, and we are speaking about 2019. The name COMPFun, thanks to JData research, was quite a public one for 5 years already. And anyway, one of the servers was chosen after the same family malware name. Oh, also interesting decision. I like such small things inside the researchers. Okay, so as a result, they let us sum up all these part findings. They mark the TLS session of their interest, even inside the big infrastructure behind the NAT, and after it, they could analyze this traffic and decrypt with using the XOR key inside the client hello field, decrypt the unique target IDs, and decide, okay, this session we are interested in, we could take this data. But the next question appears. How the traffic could be taken after all? It's so on some point between the target and between some website, between some internet location the target want to visit have to be some host, some interceptor to take it, right? So they install the certificate, they mark the packets, now they could take the data. It's up to you to decide where they could install it. It could be from same building, it could be whatever, but from my point of view, so in Ho, it's the best place to put such interceptors. For sure, it's an ISP. But during the report, we couldn't tell for sure what it's on ISP side, so it's evil is over there because we don't have enough data. We don't know. Maybe with infected files, we see our telemetry show infected files came from some virus site. Maybe it was infected on the virus site already, right? Maybe it's nothing bad happened on the ISP side. But some months passed by, and we see some new URLs also. And this time, this URL were still accessible to analyze data. So firstly, this various sites in use was not, these files on various sites in use was not accessible anymore. So no more files of our interest. But several months later, we could get the files, and these files where target tried to download and downloaded was available and uninfected. So this is all the facts. I enumerate the facts. Files was not infected there. On our target site, they became infected. And the malware tried to facilitate the meeting. Now up to you to decide where the malware could work. Okay, so something in a way happened between the this downloader, this virus website, and the target host. So, and now let us go to the part 2 of the story. So first part was about the TLS and this idea of client hello manipulation. Second part was also the malware with the same code base we came upon right after the first part. And this time spreading mechanism was not the virus side at all. Well, once again, the operator, sectors operator, was interested in diplomatic entities, and this time they spoof the visa application. Once again, these are not in terms of payment system, but in terms of the permit to enter the country. Application just to issue the visas to facilitate the visa approval process and on for the consulate for the diplomatic entities. And inside the sample, this application was there. It was a real, the application itself was inside, but not only the legitimate application. Also, the Trojan versions for the 32 and 64-bit architectures were inside. Interestingly, so inside the infrastructure, it's a shared directory on the LAN. So some employee take this from the LAN location with huge file, install this application, and get trianized after it. And this time, so infection to scheme is also seems interesting to me, but it's not the most interesting in this case. After Trojans to take the control, the communication process of these control servers is based upon with rare HTTP statuses. So what it means? If you take a look at the request for changes from the Internet Task Force, you would see a huge amount of HTTP statuses. For sure, you know the most popular one, 200, 404, etc. But there are huge amount of rarely used statuses. Like I don't think you are quite. Maybe you are. Me before this research, me not with a status like 423 or 427. You wouldn't see it in your daily life. So some funny statuses could name like not from this range, but when I take a look at RFC, some of the HTTP statuses looks like I'm a kettle, I'm a teapot. So it's statuses for all the possible situations for the online. And they use why to invent some readable commands or some codes for the commands if they have with rarely used HTTP statuses. With such a reply, it's rarely the normal server, the legit web server, some Nginx, Apache, whatever, would rarely reply to you with it 400 to 3, right? You could, during the question time, you could argue with me, but from my point of view, it's very rare situation. And they just use some subset of the statuses as a comments from the so server just have to reply with a just status, and this message body could be empty, so or to hold some arguments for the comments. Quite nice decision. Maybe in my experience, and I'm doing until now for 6 years, maybe the first malware using such a mechanism to communicate. Interesting one. And the funny thing here, they also implement asynchronous, async handling execution of the commands. They wouldn't execute it at once, and they would wait for the status 402 to run all the corresponding handlers for the previously getted commands. So it's a funny thing here. Its status is a payment required. So really, it seems to time to pay. So the Trojan begin to do its work, just to upload, download data, whatever, all this remote communication could do. So quite nice multi-threaded and asynchronous part of the work. So it's just a list what these commands could done. The propagation to the plugged devices, I could only speculate. It could be to go through some air gaps, but to tell you the truth, it's maybe speculation. Maybe they just want to spread. I don't think if the targets we didn't see any industrial targets, so maybe it's not for the air gaps, maybe just one mechanism of the spreading. So what else? So hijacking is just the same mechanism of the persistence. Maybe you remember on the first slide for the part 2 of the story. It's also used in original COMPFun, and with Reductor guys also use the same persistent mechanism. This is it. This is how they use this first. The popular one is 200. You see on the first slide. It's just the way how to say okay. So the command server have to reply once with a normal HTTP status. All the another one are not so popular. And let us also take a look a little bit at the encryption schemes here. They are, from my point of view, the encryption here, it's by the way, two parts which I try to cover in any report. It's a persistent part and encryption part. So for me, it looks like so useful in any report, besides all the indicators of compromise, all the tactics during the campaign, because it's maybe the targets want to decrypt the data on their side, which was gathered by the what they gather, whatever, and persistent just to rid off of the current campaign. So in this case, encryption in use was RSA mostly, because the corresponding RSA key was encrypted in the configuration data of initial model. Once again, please who want to take a look a little deeper in these technical matters, please consult the securelist.com. website with all the technical details. And what else? With the compression, they prefer LVNT1. No, it's because of the usage of the Windows API. Maybe you know the Windows API it's quite with the RTL compressed buffer function, quite easy to use such an algorithm. And good old SOR and advanced encryption standard IS is also here. One more thing worth to mention, it's the usage of the HTTP ETAG. Originally, ETAG was introduced many years ago in HTTP to provide caching, not to reply with all the same traffic from to the same request from the same server. But I believe in this case, for sure, it's not about the caching. This unique ETAG, also encrypted into the configuration data, it's mostly to avoid the internet scanners or other the host which try to contact the control server, but it's not the target. You know, if you now would just create new DigitalOcean, whatever VPS instance, and you just enumerate all the scanners which came to you, all the shorthand crawlers, etc., and you would see just in half an hour, you would be huge number of the requests. So I think the ETAG usage is the avoidance of such unnecessary for them, for the C2 traffic, to only to reply to the request from the target of them, not to the crawlers, not to the scanners. Also quite a good decision, I think. This is it. What was about the encryption on board. And this is maybe the most philosophic slide I ever made because it's almost empty. And this, I hope, with my English, I name it right in English, with partial sum of the row. In Russian, it's if somebody here speaks Russian, just in case, частичная сумма ряда. So partial sum of the row, it's what we found inside the sample. It was returned by separate function and was used as a timeout. Remember, this malware is multi-threaded. And if you use multi-threaded, okay, so no coroutines, no real async await back then. And by the way, it's a usage of C. It's even, you know, it's like a C++, but mostly C. You know, when a programmer develop all the lists and all the vectors by himself, not using the STL, but all the structures developed by the author of the software. So it's more C-like approach back then. So one function, and they have to make some mutexes, some synchronization of the different threads, right? And this function returns the timeout to wait for another thread. And when I take a look at it, and when I understand what it counts, it's a count with sum, when you see on your screen. And I wonder why, what is it? And my university days was so long time ago, and I maybe who from you, it's online, pity. If you will be offline, I would ask the audience who is familiar with such a row, and I believe someone is familiar, but it took me to consult with my mates from the university who remember it. I could tell you guys, this is the exponent. If you want to write the exponent as a row, you could count with not the partially sum of the row, but the full sum of this row would be the exponent of the argument of the A. So some function return exponent, and it's also good. And you know, for some time I think why they implemented. And my theory is it's a good way to synchronize things. Imagine you have a client software and server software, and your client make a tuk-tuk. I want something from server. I don't know, some microservice, and you want to get some JSON out of it, but server doesn't reply. Nah, I'm not functional now, and client have to wait. Client, one approach, client could wait just a constant time. It's not good because it's, for example, every second, every 5 seconds, or every minute, it would make a tuk-tuk. Is anybody there? Microservice is still unavailable. It's a good idea to make this timeout exponential, because if on the server side, on the microservice, they have some small problem, maybe it would reply just not in 1 second, but in 2 seconds later, right? But if they are completely unavailable, I don't know, the power outage, whatever, maybe it's a good idea to wait larger and larger amount of time, and the exponential growth is good here. So I really believe these guys have a good programming experience because of such a decisions. Let me enumerate it. Time of wait for the synchronization, this idea about the patching of the parent JIP pseudo-random number generators in memory, and this idea to use HTTP statuses. I like it. I like it. It seems to me like a creative kind of a malware. Enough for the math, for this small piece of math. And now I think we are done with the part 2. And I promise you the third part, the last maybe around 15 minutes of the talk before the questions. Let us discuss 2 approaches. 2 approaches to do or to use. What I mean here? For me, during the analysis of the malware, 2 ideas, you could reuse the code malefactors already provided. For sure, if, for example, malware needs to decrypt the next stage, all the code, all the right code is inside the malware. Otherwise, it wouldn't work on the target host, right? And if somebody is good with the debuggers, breakpoints, dumping from memory, the first approach, don't reinvent the wheel. Just use the code you already have. Yeah, it's quite an approach. But the second one, if you want something to do right, do it by yourself. So what it means, no dynamic analysis, just a more static approach when to decrypt or do something with this sample. It's also just to write your own decryptor or your own part of the software to fulfill this task. Okay, let's take a little bit deeper look into these 2 approaches. What you prefer, don't invent the wheel, or like Mr. Trump did here, do it by yourself, build the wall by yourself. I have it, now it's another research. I'll just take it as an example of the second approach. What we've done, if you decide to do it by yourself, to build your wall by yourself, we have samples, and it was using the steganography. So on the first stage, it was decrypted the URL to take the bitmap picture from the legit website. Cloudinary check for it once again, completely legit. So take it on the second stage, decrypt it, inject it into system process memory, and the last stage is here to taken from the BMP file and ready to communicate with the C2. And we wrote the decryptor as a standalone application. We don't use just debugging, breakpoint, dumping, whatever. We wrote an application. So what we need here is just just a small C++ app with a 2 mode of work. You just let the app know I want to decrypt the config or I want to decrypt the bitmap picture, just to remove the steganography, check from the file with the steganography, because case scheduling differs because of the site. Because config is much smaller than BMP, and in this case, case scheduling differs, and algorithm is a quite custom ones. And from the configuration, it could get the target ID, URL of the picture. I'm quite sure it's constructed with a builder. So typically, campaign operators have some applications not spread among the targets, only on the operator host. They enter some parameters like a target ID, URL, press the build button, and they get the initial infection after it. And in the bitmaps, only one, besides the network model itself, besides the last stage Trojan, only C2 domain was decrypted. So as a result of this small C++ app, we could get the URL of pictures, we could get the next stager, and the C2 URL. This is it. This is it. And just two cases, minus you can see, minus C for the config, minus B for the VMP. And if you compare with a decision during the research, once again, another research, not related to the COMPFun, if you compare it with our two pictures, for sure, it's a Mr. Trump's way. Do it by yourself, don't reuse the malware code. And why I think it's preferable. Let me be for a while an advocate of such approach, because all this COMPFun research was built on this approach, on your static analysis, quite deep static analysis, don't reuse the code, write your own code for analysis the samples, etc. First of all, it's acknowledged separation. For example, here, what I mean, in case of this Makachean research, we put this decoder, this decryptor on a GitHub. So on a GitHub, and if imagine for 3 years, 5 years passed by, and I forgot almost everything about this decryptor, but I still have the source code for the decryption. I'm quite sure 3 years later, it had to be changed in terms of this custom algorithm of decryption. For sure, malware authors would change the algorithm, but all the knowledge are separated from the researcher. Researcher could move to another company, could even don't do trade and shell anymore, or could forget everything about this research already, whatever. Knowledge is separated. I think it's a good idea. And during this approach, build your own wall by yourself, it's I think it leads to real understanding of the insights of this malware. It leads to the better Yara rules, or to better Suricata rules, etc. So you really understand the protocol, communication between the C2 and the Trojans. You really understand the encryption schemes, whatever. You really understand that all these features like a multi-threading, how they communicate to each other inside the models of this campaign. And also, it's this third point connected to the first one, high reusability. And if you imagine you have 2 dozens of samples, not only one, and you want to take all the common server from it. And if you don't want to reinvent the wheel, and if you want to reuse the malicious code, you would open all this sample in your debugger on your IDE Pro, whatever, just to dynamically take the decrypted C2 out of it, right? And I think it could be a time consuming a little bit. If you once wrote the application, which is also time consuming, but you once wrote it, and you could happily just feed all these 2 dozens of samples to your application, you could pipe it in your, just make a one-liner using SACs, whatever, the tools of your choose, make a one-liner, and you happily get all the next stages, all the URLs, all the parameters. I think it's could be in terms of you have some dozens of samples, you could even save your time despite the programming time you spend on your utility. So this is our pros. I could name for the second way of doing the research, but let us be honest, for sure, first way has its own pros. Otherwise, nobody would use it, right? And first of all, for sure, for the very one sample, you with a debugger and with dumping, memory dumps, you most probably do it faster. You don't need to write your application. By the way, if you have some template and you just have to add some new decryption function, it's became quite faster in doing the new decryptors. And maybe you just don't like to code at all. For sure, many of the analysts are preferred to more familiar and very fast with dynamic stuff. and dynamically could take all this data, decrypted data, like URLs, faster. Okay, and maybe for me, the main plus of the approach "don't reinvent the wheel," it's a far less error prone. What I mean here, when you copy and you write your own copy of this malicious code to decrypt, I mean the decryption part, not the malicious functions per se, you could be tried as like this guy. I see on his screen it's not a programming, it's something like a Wikipedia, by whatever. He has some coffee, has some laptop, and sometimes during the debug, you could, of your application, you could feel like him. If the encryption scheme is quite tricky, it's, why I don't config with IS 256 to the common function. They just make, wrote some zeros in the end, whatever. So sometimes during your building your world, you could be tried. And for sure, if you reuse the code from the malware, yep, you are on the safe side. Once again, malware, if malware wants to work perfectly, it has to be implemented right inside itself, right? So you could just execute on your virtual machine the code. I think this is also, I think I'm on time, 40 minutes, like promised, 40 minutes plus. And let me sum up before the question. So we covered 2 stages of the research of the COMPFun like malware, which I covered, from my point of view, interesting tricks like pseudo-random number generators, compromission inside the process memory, usage of the rare HTTP statuses for the comments from the control server, and all the little tricks like exponential growth of the waiting time during the thread synchronization. But besides the covering this campaign itself, I also emphasize these 2 possible approach, and to mostly doing like an advocate of the approach build, not reuse, right? Okay, reuse your own decryptor, your own emulator of the C2 to understand the protocol, whatever. So now I think if you're interested into the source code of the decryptor, it's GitHub is at your service. I publish it, but it's just, I think you could easily write it by yourself, so nothing special, just C++ and some decryption functions. So some small framework to decrypt whatever. And what else? If you don't, now we have around, I suppose, 20 minutes for questions. If it would be not enough, please feel free to ping me on some social networks like Twitter, Facebook. So you could easily find me somewhere online to ask something. Okay, I think I'm done. So please, if you have time, I hope so. Let's ask. Let's discuss. Thank you. Thanks for attention.
Thank you, Denis. Unfortunately, we did not get any questions on this topic, so I guess your explanation was spot on.
Nobody's interested in such a topic.
Oh, come on.
I hope not. But in Singapore, it's already 10, almost 11 p.m. Let us hope it's because of the time and the clearness.
Well, this
maybe
talk...
Cooper, maybe you have some questions.
I've been watching, I've been thinking, but like, I understand what you're doing here, so yeah, I'm sorry, no.
Okay, so if it's no questions, then thanks again, and hope to see you on the Hack in the Box again.
Absolutely. To the people at home, we will be back again tomorrow. We start at for Singapore, obviously, a very reasonable time of 10 in the morning. We will then have as our opening keynote Eddie Schwartz with his talk, Are We Far Enough to the Left Yet? DevSecOps, Chaos Security and Not Being Left Behind. Please tune in for that one. We will have another packed day that again ends around 10 o'clock. in the evening. So if you think you might have nothing to do this weekend, think again. We hope to see you there. Have a nice evening.